Okay, can. Right, let's begin. Okay. Is it better, the echo?
Yeah, can.
Yeah. Okay. Can. So the issue here is that most of the questions you can do. It's just that you made a careless mistake. You miss a negative sign here. You miss a negative sign there. You forget to distribute one of the terms. You compare coefficient. You look at the wrong coefficient.
Right.
Then you just have error carry forward. Okay. Okay, now let's begin. So question one, z equal x plus iy. What you did here was you substitute the z with x plus iy. That's okay. You get the x, get the y. For this question, it's okay, but later on you realize that this may not always serve you very well because over here there is a simpler way. There is a simpler way. Let's take a look at the solution. So yeah, take a look at the solution. So what we have here, z minus 2 over z equal 1 plus I. So how do we do it? Actually, what do you realize? This is actually just a linear equation in z. If this was just a normal x, can you make x the subject here? Can you make x the subject? Yes.
Can.
Yes, you can. You just need to times the x over, right? So you get 1 plus, okay, I'll just look at the actual question, actual solution. So the z you times over, you get 1 plus I times z. Then you want to make z the subject. So what do? Here got z, separated. Bring them together. So bring it over. So you get a minus. Plus become minus. Then the minus 2 bring over as well, become plus. You got a factor of z, take it out, factor out. Then you're left with 1 from the first one, then minus away 1 plus I. Make sure you distribute the minus sign, so you get negative 1, negative I. Oh, negative 1, negative I. Then how do you solve for z? Just divide. Okay, just divide. Sorry, 1 minus 1 in this case is just 0. So 0 minus I. Then you have to divide by negative I. I think you forgot. You really forgot a lot of times.
Oh, yeah.
What do you need to do when you have a complex number at the bottom?
Last times the conjugate.
Exactly. So a lot of steps, you stop halfway. I'm like, it's division. What do you do when there's division? Multiply top and bottom by the conjugate, right?
Oh, okay.
Yeah, so I think you forgot that step. That's why you couldn't do most of the questions. So I times I is I squared, then extra minus sign, so minus negative 1. Then you get a positive 1, so 2I. Okay?
Okay.
Yeah, can. Next one, let's see. Good as well. Okay, nothing to go through. Okay. Question 3. We went through question 3 already. Your first part is okay, but you did something wrong with the next part, I think. Yeah, draw a line. Good and not so good. Okay, let's take a look. So over here, the question start you off with z squared plus 4z equals minus 9 plus 12i. What you need to understand is that this is a hence question. So you need to use the first part. Do you understand the meaning of hence?
Yeah.
Hence means you have to use the answer from the previous part. Even if you didn't manage to prove it in the previous part, you can still use the result from the previous part. So let's take a look at the question. Wrong. Should be like this. Let's take a look at the question 3. Question 2 is okay, perfect. This guy, they tell you blah square equal to minus 5 plus 12y. Oh, okay, they didn't tell you the exact answer, but they asked you to find the possible values and you managed to find it. What you managed to find here, x plus y, is really just the square root of minus 5 plus 12y. Okay, x plus yi bracket square equals to minus 5 plus 12y. After you solve for x and y, what are you essentially doing? You are taking the
square root.
So plus minus square root of minus 5 plus 12y. Maybe I didn't explain clearly. That's your answer to x and y. In this case, actually you could have just used a calculator directly. You could have just used the GC directly. Right? They never say without GC. So x equals to 2, y equals to 3. Then x equals minus 2, y equals minus 3. Right? You can use a GC. Yeah. So therefore, the answer would be this is equal to 2 plus 3i or minus 2 minus 3i. Those are your two answers. Now, what does it mean now? It means that we need to make use of this fact. Square plus minus square root of this negative 5 plus 12i give you these two answers. Take a look at what you did. Oh, yeah, wrong way. Should be like this. Take a look at what you did. What you did is you replace the z with x plus iy. Okay, that's fine. But then up to this step is okay. Sorry, I should put a tick here. But over here, there's a problem from the blue to the blue. How do you know for sure that this x and this y are? Okay, I am assuming that you understand that the z here in this new equation, the x and the y is no longer related to the previous part. Is that clear to you?
Yeah.
Right, so the x and the y may is not guaranteed to always be +2 and +3 or -2 and -3. Okay, oops, sorry, I missed out a minus sign here. Over here, I missed out a minus. let me write it nicely. Like this. Oh, there should be a minus sign there. So since we know that they may or may not be a +2, +3, or -2, -3, that means that we cannot immediately replace with -5 plus 12i, right?
Yeah,
This
cannot.
is only true only when the x is 2 and y is 3, or when x equals -2 and y equals -3. How do we know that? We don't, right?
Yeah.
So that's why a recommendation to you here is that instead of writing x plus iy, which is confusing, you may assume that they are the same. That's why you did this substitution. What you should do is to use different letter. Okay, maybe p plus iq or something, qi.
Oh, okay.
Okay, then you solve for p, solve for q. And then I think if you write down p plus iq, you definitely will not substitute in with -5 plus 12i. That's totally wrong. This step. Okay, so since this step is wrong, everything else is wrong. So what is the strategy here? I wrote down a procedure for you here. The strategy is you need to make sure that the right hand side you get a -5 plus 12i. Currently we have, I think, -9 plus 12i. Yeah. Right. How do you go from -9 to -9 plus 12i to -5 plus 12i?
Maybe can bring over.
Bring over. -9 is the same as -5 plus 12i, and then you -4.
Yeah. I think.
Then bring
So
over.
bring over +4.
Bring over the -4, you get a +4 on the right. So what does it become? Z squared plus 4z plus 4.
Yeah.
Then you got 3 terms as z squared plus 4z plus 4. But my step 2 tells you to rewrite the left hand side as some happy face to the power of 2. So what do you need to do?
Complete the square.
Complete the square, exactly. Okay, I already went through this last week. So complete the square, you get a perfect square like this. Happy face with a power 2 equals to -5 plus 12i. Then what can you do? Now solve for happy face. So you need plus minus square root of 5 plus 12i, which we already solved just now. To be this, which is what you got just now. Now 2 plus 3i and -2 minus 3i. Then after that, you can solve for happy face. In this case, happy face, I believe it is a z plus 2. Let's take a look at the solution. So blah blah blah. Yes, you got the correct x and y. But the next part here, z squared plus 4z equals to -9 plus 12i is the original question. You're supposed to rewrite it such that you have -5 plus 12i and z plus 2 bracket square on the left hand side. The question, what they did here is instead of splitting up the -9 straight away, they rewrite it as they complete the square first. So you have a -4, -2 square, right? Do I need to explain this part?
No.
I better explain. Don't need. Okay, good. Then after that, the -4 you bring over become +4. Then you get -5. Then from here, you take the square root. So that's why you get the 2 solutions. But it is no longer just a normal z, it's z plus 2. Z plus 2. Can understand?
Yeah.
Yeah, then after that, you -2 on both sides. Okay, we went through this last week. Let's go on to the next one. Question 4. I am okay, it's well done, but I'm a bit confused by what you're writing over here. Z is identical to 5 over z. Why is that true?
I was writing divide, I think.
Oh, wait, let me read again. Divide means you flip times z over 5. That's still not correct. Here is z, here is also z. Z divided by 5 over z is z multiplied by z over 5, which is z square over 5. Right? Why do you have z square over 5? You mean, yeah, I don't understand.
Because the question is z divided by z square. So I did it like
Square? Z star, you mean?
yeah. The
Oh,
conjugate.
conjugate, yes.
So I did that I did z divided by the z conjugate. Then they give me is equals to 3p plus 4/5 I. So I just equate them together in the second step.
Let me think a bit. How do you calculate Z? What is Z? Can you tell me?
The x plus iy.
Okay, can. Wow. Oh, I understand now. Okay, I understand now. Right, I get it. I get what you're saying. So you're saying that, so what you did is Z over Z star a fraction. You rewrite it as a divide, Z divided by Z star, correct?
Yeah.
Then over here, Z star, you make Z star the subject. So you get 5 over Z.
Yeah.
Then after that, you replace the Z star with 5 over Z.
Yeah.
And then they already told you Z divided by Z star is 3/5 plus 4/5 I. Oh, okay. That makes sense. Wow, but you need to give a bit more context because my brain very slow. I couldn't follow. I couldn't follow. Huh? How come suddenly got triple? I didn't. Oh, that's a divide sign. I thought you were writing three lines of hamburger identity.
Oh, okay. I
Okay,
better write down. Okay.
sorry. Yeah, just okay. Then anyways, your working is fine now. Perfect. Very good. Yeah, good means don't need to go through already. You got it. Okay, we're gonna move on. Question 5. Question mark. You have a circle. What happened here? There's a missing negative sign right from the beginning.
Oh, oops.
1 minus 16 is negative 15 now. So the error carry forward all the way. Anyways, conjugate is not 15 plus 8i. It is negative 15 plus 8i because of error carried forward. And anyways, using conjugate root here is not useful. Oh yes, one more thing I need to bring up. I think last week I mentioned fundamental theorem of algebra. I'm wrong. It should be conjugate root theorem.
Oh,
I think you realized that. Right. Conjugate root theorem. Yeah, just plus become minus. Okay. Yeah, fundamental theorem of algebra is saying that if it's a power n polynomial, then you have n roots. Power 2, then you have 2 roots. Power 3 got 3 roots. Power 4, 4 roots. At most 4. At most 3. At most 2. Yeah. Okay. Let's see. What is this question? I can't remember. What is question 5 talking about? Express 1 minus 4i squared in the form of a plus bi. Okay. Then you want to find the roots of this guy. Okay, let me just go through the correct solution first. So over here, 1 minus 4i squared, you can just use a calculator to be honest, but since they said no calculator, then you just show some working. You get minus 15 minus 8i. Careless mistake, you forgot the minus here. Forgot the minus over here. Then after that, they tell you something in the bracket square is equal to 15 plus 8i. What do you notice about minus 15 minus 8i and 15 plus 8i? They are?
the conjugate.
No.
Oh, they are like negative. Like
Yes,
negative.
you can factor or negative here. Correct. They are not conjugate. Conjugate means you must change the a plus bi to a minus bi only. Here there's a positive 15, here there's a negative 15. They are different a values, so they are not conjugates. Okay, but what happens when you got a negative factor out? It's really just negative 1 multiplied by 15 plus 8i. So negative 1 is really just I square, right?
Yeah.
Why do I want to do that? Because minus 15 minus 8i, you already know that is 1 minus 4i squared. So that means you can also replace this with 1 minus 4i squared. Then now you got square on the left, square on the right. So you can rewrite it as I times minus 4i bracket square. What's so useful in doing that? Look at the left hand side. You got something square. Right hand side, also something square. Then you just take the square root. They wrote it over here. Something square equals something square. You can take the square root, but then you need plus minus. So positive 4 plus I and negative 4 plus I. Make sure you distribute the minus. And then after that, you solve for Z. Do you need me to show you how to solve for Z?
Don't need.
Don't need. So you just 3 bring over minus 3, then you times 2. Same thing for the other guy. plus 3 bring over minus 3, then times 2. Okay, so that is the solution. Let me see your working again. What exactly did you do? Okay, you substitute in x plus iy. This method will work, but it's very slow. Not recommended. Okay, but it works. I don't recommend it. I strongly don't recommend it in this case. Sorry, maybe I didn't explain it clearly enough last week. You don't just substitute x plus iy. Sometimes you need to use some special identities. In this case, the trick is to make use of the previous part. Then you solve the current question.
Oh.
Rewrite it as something square so that it's easier to take square root. Okay?
Okay.
Can so you can see what I did here. I just followed through with your working, but then up to this step is okay. But it's just that you missed out on the coefficients here. 2xyi and 12yi. So there should be a 2 here, there should be a 12 here, it's missing. Then you equate to 32. Okay, you see the coefficient wrongly. Careless mistake. Okay, so otherwise you could have solved this. Then you get this equation already. I wrote it over here. Then the rest I ignore already. I simplify, I eventually get to y multiplied by x plus 6 equals 32. I basically try to factor out the y. Then I solve for y. I get y equal 32 over x plus 6. It's something like this. I believe x equal negative 6 here. You can use a GC to draw it yourself. I call it equation 1. Then now I got the second equation, x squared minus y squared plus 12x plus 36 equals to 60. You compare the real part, you get this guy. Straight away, I hope you realize this is the equation of hyperbola. Do you see that? I forget already.
Kind of forget already.
Okay, hyperbola got two formats. It's either y squared over a squared plus in front of the y squared, then minus x squared over b squared equals to some c squared.
Or this one
x
can see,
Can see, okay, the key thing here is you need to realize that. Let me just finish writing it. The plus sign in front of the y means that it will look like a y shape. It will look like this. Okay, can you see a y?
Yeah.
Maybe I sketch it nicely. Curve like this, curve like this. How I memorize it is positive sign means positive in front of the y square means it will have a y shape like this. Right? Some people write their cursive y like this. They curve it down like this. So you can see a hyperbola. That's how I memorize it. Then the positive x squared. Positive x squared means that you have an x shape. So it's the other way around. So you got the two oblique asymptotes, and then you got the C, like this. Can? Okay. Yeah, then the reason why this is you can see that it will eventually become this format, because if you bring the x square over, you get minus x square. So you get plus y square minus x square. Plus y square minus x square, you're expecting this kind of equation already. Okay, you can eventually just need to do some computing the square and so on and so forth. Okay. And maybe just to be more complete, it should be y minus q square and y minus p square. P comma q is the center. Okay, well, this is not the graphing lesson. We will not talk about it. Let's move on to complex numbers. Yeah, so now you got this guy. How do you draw this in GC? You can use a special conics function, but that's not recommended, because what we want is to make sure that we got the equation 1, 2, and 3, and we want to solve them simultaneously. We want to solve for x, solve for y. So we have to cannot use that. We have to use the graph function. So what we need to do is to make sure that we get y on its own. How do you get from y squared to y on its own? You take the plus minus square root. Can? Then plus minus square root is essentially two equations here and here. Then you can just label them equation 2 and 3. So I said here, using the GC, you can sketch the graph 1, 2, and 3. Then you find the points of intersection. Then you can solve for x, solve for y. Then you will get your answer.
Okay.
That's not recommended. Strongly not recommended, because it's very slow. You see the working you do. Look at the amount of working you're doing. And you still make careless mistake along the way. Compared to the solution, look at it. So much shorter. That's it. That's the answer already.
Oh.
Oh?
Okay.
So every time they tell you something in the front, express as whatever, it's a hint to you that you need to use this. On the left side, there's a square. Here also got a square. You need to see the pattern. Then I think you would have been able to see the pattern if you didn't make the careless mistake of missing out this negative sign. I think if you got minus 15 minus 8i, you can immediately tell they are negative of each other.
Yeah.
Then from there, you could tell, hopefully, that it's I square, and then you can factor as something square. Okay?
Okay.
Can Oh, by the way, solving quadratic equations, the first step should always be, the easiest form should always be square root. Oh, you see a plus b square, you don't go and open up. You usually want to take the square root. Okay, Ken, moving on. Question 6. Circle. Something is wrong. What happened? Z square is fine. Z cube is wrong. You're missing a negative sign here. Minus 3 minus 8 is negative 11. You write down positive 11.
Oh.
You know, you could use a calculator for this, right?
For Z cube.
1 plus 2i is Z, then Z cube is 1 plus 2i power 3. You want me? Okay, I'm just gonna show you on the GC. If I could just open
So they
this.
don't need to see all my expansion.
If they never say, if you only need to if they say without using a GC. Otherwise, you don't. Yeah, don't need.
Oh, okay.
Oh, they did. Sorry. Yeah. Sorry. I didn't read the question. Without.
But can check, I guess.
Yes, correct. Yeah. Let me just share screen. This one. Okay, maybe I should share the calculator itself. Okay, Ken. What do I want to type in? I want 1 plus 2i bracket power 3. So bracket 1 plus 2i, close the bracket, then power 3 equals minus 11 minus 2i. See the negative there?
Yeah.
Okay, let me see if I use detach LCD. Yes, minus 11. Okay, the screen is not very big, whatever. Okay, moving on. Let's change it back to the iPad. After that, you do 1 over. You can also type using a calculator, but you cannot type in 1 over, okay? If you want to check using a calculator, you do not type in a fraction, 1 over minus 11 minus 2i. The calculator cannot handle fractions for complex numbers. You have to type it manually. 1 divided by open bracket minus 11 minus 2i. Is that clear?
Yeah.
GC, because GC is funny. I'm not sure why. They can handle this, but they cannot handle this. They don't understand fractions. But anyways, this is without using a calculator. How do you calculate 1 over a sum of 2 numbers? Let me ask you a quick question. Over here, is 1 over 8 plus 2 the same as 1 over 8 plus 1 over 2?
No.
No, okay,
Yeah.
good. You can tell straight away when it's normal numbers, but the same thing applies even when it's complex numbers. I quickly check for you that they are definitely not the same. Left hand side is 0.1, right hand side is 0.625. But how about over here? What do? You split it up. Are you sure you can do this?
No.
No, definitely not. Okay, so let's see how we can do this. Every time you see a fraction, division in complex numbers, what do you have to do?
Must times the conjugate.
Yes, conjugate of the denominator.
Yeah.
Not the numerator, must be denominator. Okay, so you must multiply top and bottom by the 11 plus 2i. Okay, so now let's so that means that error carry forward all the way. All the way is wrong already. Yeah, sorry, but I'm not sure why. Very, very interestingly, even though your working is wrong, your answer is still correct. The 19p, I don't know if it was designed by the question when they predicted a student would make this kind of mistake, or did you somehow have some intuition for the answer? Because you got the correct answer, but the working is wrong.
Oh.
I don't know how that happened. It's like pure coincidence. Very scary.
I just solved all my wrong working. Yeah, I think they purposely want.
Yeah, maybe. Okay, let's take a look. So find z square, find 1 over z cube. Z square, you got it. Wait, do you get it? Let me just double check. I can't remember. Yeah, z square, you got it. Z cube, you didn't got it. You missed out a minus. Then 1 over z cube, also wrong. Haven't simplified. So yeah, z square is minus 3 plus 4i. Then 1 over z cube, it will just be 1 over z square times z. Then you multiply out, you get minus 11 minus 2i. That's fine. You don't need to show the working for this one, to be honest.
Oh.
To save time out, you can work it out at the side, I guess. Then after that, what happens? Oh, actually, no. You can cheat a bit. You just use calculator. This denominator, just use calculator.
Oh.
Oh, show some working. Pretend that you are actually multiplying, but actually just use GC.
Oh.
Oh, this is a working needed. Can already. If you can do the first part, I'm sure you can do the second part. Then you can save time lah. Just use GC. So you got denominator already. What do you need to do? You're supposed to multiply by conjugate. So negative 11 plus 2i over negative 11 plus 2i. So a plus b times a minus b is a square minus b square. So negative 11 square plus 2i square. Of course, you can also use a calculator to calculate this. Don't need to expand manually. Oh, that's a 121. That's a 2i square becomes 2 square I square, which is really just 4 times negative 1. So it's 121 minus 4. I think. So let me double check first. Sorry, I forgot to put a minus sign here. Should be a square minus b square. Sorry. Then this will become minus negative 4, so it becomes a plus 4. So 121 plus 4. Is that okay?
Okay.
Or in other words, 11 square plus 2 square. Then you just multiply the numerator by 1, but then they factor out our minus. So negative 11 plus becomes plus and negative. So far, okay?
Yeah, can.
Then simplify into 125, then you split out. This part, okay?
Yeah.
Can okay, so that's the answer. Negative 11 over 25 plus 2 over 125i. That's part 1. We're not done yet. Now we got part 2. You are given that you have real numbers p and q such that pz squared plus q over z cube is real. You want to find in terms of p the value of q. You got q equal to 2p, but the answer is actually way more complicated. It's negative 250p. But somehow you got the correct answer.
Wow.
I have no idea why. Totally different working, but you got the correct answer. I have no idea why. I checked your working, yeah, and it works out. It was probably planned by the question setter. They predicted the kind of careless mistakes that you'll make.
Oh,
Very
no.
evil this question.
Yeah.
Okay. Yeah, okay. So pz square plus q over z cube is real. Find in terms of p the value of q and the value of pz square plus q over z cube. So you want to find q first, then after that you solve for this guy in terms of p. Substitute the q with whatever you found. Okay, so our goal is to find q. What do you understand by real? I think you know this already. It means purely real. So the imaginary part of pz square plus q over z cube is
0.
equal to 0. Exactly. Good. So that's what we're going to do. How do you get the imaginary part? So pz square plus q over z cube. You can just sub in the z square and sub in the z cube. Maybe a nicer way to write it would be p times bracket z square plus q times 1 over z cube. They are the same, right? Then now you can see immediately. Sorry?
Yeah.
1 over z cube, you got the answer already. So you don't need to go and 1 over again. Let me show you your working. What you did was you did a 1 over here again. That's wrong. What you did was you are substituting z cube with 1 over. That's not correct. You see in the previous working,
Yeah.
you already got z cube is this one. Then 1 over, you already did the 1 over to get the 1 over 11 minus 2i. Then here, you took the 1 over z cube and you substitute in the denominator. That means you're going to flip it again. That's wrong already. The denominator here should be a z cube only, which is 11 minus 2i.
Okay.
So yeah, another careless mistake. First one is negative sign. Second one is substitute wrongly. Okay, this should just be a normal minus 11 minus 2i. Okay?
Okay.
You see this working? I explained it a little bit. You can go and read it a bit. Yeah. Okay. Solution continue. So what do we know about the what were we doing? Yes. So over here we are replacing the z square with minus 3 plus 4i, the 1 over z cube with this negative 11 over 125 plus 2 over 125i. You distribute the p, distribute the q, you'll eventually get this expression. Okay?
Okay.
Then after that, you just combine the real and imaginary parts. I strongly recommend that you do this step. I strongly recommend that you do this step. I noticed that you usually skip this step. I know it's obvious, but I strongly recommend that you do. Write down the real part and the real part. Then you combine together on the left side. Write down the imaginary part. The imaginary part. Then you combine together on the right side. Bracket, factor out the I. Okay.
Okay. Can.
Strongly recommended. Yeah. Do this. So you can see immediately real, imaginary. Then in order for this to be purely real, imaginary is equal to 0. Solve for what is it? Solve for Q. Yes. Make Q the subject. Then you can get negative 250p. Then after that, you just look back at your expression. Then everywhere that you see a Q, you replace with negative 250p. Okay. Then you just multiply out. You eventually get 19p. Okay, good. That is your question 6 part 2. Moving on. Question 7. What happened? This one just reminder again. You need to realize the denominator. Whenever you got imaginary unit appearing at the denominator, you need to realize it. So multiply top and bottom by the conjugate of the denominator. Okay, so let's see. Few mistakes over here. Careless mistake number 1. There's an I here. There's no I here. Can see or not? You forgot an I. But even if that's the case, it doesn't help you lah. Because here at the denominator, there's also a I. A minus IB at the denominator, and then there's an I outside. That's not good because what you did next, what do you do? Oh, you didn't, you just stop here. What you need to realize is straight away, when the denominator got an I component, you need to rationalize the denominator, or rather realize the denominator. Multiply by conjugate. So let me read the question first. I can't remember. What exactly they asked. Okay, got question 7. Complex number W is this fella. You have A and B are non-zero real numbers. W star is the complex conjugate. W square over W star, they tell you purely imaginary. Find the possible values of W in terms of A. Okay, let's just go through the solution. Let's see. So we got W square is A plus IB, then square, and W star will be A minus IB. This one, okay?
Yeah, can.
Can. Then, oh, by the way, your presentation, please, whenever you're trying to find a specific expression, you don't write down the intermediate working like pieces and pieces together, piece by piece, and then you join together. Just write them all together, and start off on the top left-hand corner with the expression you're trying to find. W square over W star. Make sure you write that down. Okay, your presentation. You don't just start off. You don't. I see what you usually do is you don't write this. Then you just start off with this, and this, and then this, and then this.
Yeah.
No. You need to include the left-hand side as well. The expression W square over W star. Okay. Now next we need to rationalize the realize the denominator. What do I mean by realize? It means I have to convert this complex number into a real number. How? Multiply by A plus IB top and bottom. Because I multiply by A plus IB, the numerator becomes a cube. Is that okay?
Yeah.
Okay, good. So you got cube over A minus IB times A plus IB. So that's really just A minus B times A plus B, or X minus Y times X plus Y. You get X squared minus Y squared. That's a famous identity you have to know by now. So X in this case is A, Y in this case is IB. What happens if you square them? You get A squared minus IB squared. IB squared is I squared B squared, which is negative B squared. With a minus in front, you simplify into A plus B squared. Sorry, A squared plus B squared. Is that okay?
Yeah, okay.
This one I write down as a scratch work. You don't have to show this. You can just simplify straight away to A squared plus B squared. Okay, then the numerator, how to expand? Do you know what is the formula they are using over here?
I think the formula. Oh, I always expand.
You always expand part by part, right? I saw that in your other working. Not so smart, not so fast as well, very slow. I believe high management is also an issue. Please make sure you use the formula for binomial expansion. Let me show you if you do it manually, how you would do it. you say a plus ib times a plus ib, and then you get a square plus 2abi plus ib square, so negative b square. Okay, at least you can do some intermediate working in your head. Good. I would strongly recommend that you rewrite it so that the real part on the left and the imaginary part on the right. Then after that, you do a square minus b square plus 2abi, and then you multiply by a plus ib. Is that what you do?
Yeah.
Okay. Then I'm trying to follow your pattern. Then you get a times a square minus b. Wow. Then I get very confused already. You're multiplying. Usually how I like to do it is I take the first term, I multiply everything else. Take the second term, multiply everything else. Take the third term, multiply everything else. Okay, so I'm going to follow that sequence. Is that clear to you?
Yeah.
Okay, so a squared times a, then a squared times ib. Maybe I'll draw the arrows first. Like that. Okay, then a squared times a cube. A squared times ib, positive a square bi. Next one, erase the pink arrow. Let's move on to the second one. What we get? Negative b squared times a, so negative ab squared. I like to write it in alphabetical order so it makes my brain work. So because that's how my brain works, I like things in order. B squared times a, I don't like to write it as that. I like ab squared, nicer. Then negative b squared times ib, what do you get? Negative b cube I, negative b cube I. Okay, so b cube I. I like my real numbers on the left side and my imaginary on the right side. Less confusing. That's my standard way of writing. So next, next one, third one, multiply. So 2abi times a is 2a square bi. I think so, yep. So 2a square bi. So plus 2a square bi. Maybe I'll put it on the left here. And the next one will be, maybe I'll change the screen, change it to screen mode. Okay, good. Can see. So 2abi you want to multiply by the next guy, ib. So 2ab times b gives you 2ab square, positive. But then you got I times I, which is -1. So minus 2ab square. Then now I got all my real parts and all my imaginary parts separated. Yeah, so you could do that. That's a bit slow.
Yeah.
A bit slow. And I don't know if I made any careless mistakes or not. Let me just check with the answer later. On the left side. Close the bracket. That was the numerator only.
Yeah.
Oh, I forgot to simplify. Minus ab square minus 2ab square is minus 3ab square. Yeah. Minus 3ab square. And then here you got anything else to simplify? Yes, there's a 1a square b, there's a 2a square b, that's 3a square b. Oh, so let's write that down. Yeah, so you can see that it's very troublesome, right? You still need to combine like terms, get the 3. If only there was a faster way that we could have calculated the coefficient here. If only there was a faster way. Coefficient. You got something with 2 terms inside. Bicycle also got 2 terms. So binomial. Oh, very smart. Finally, remember already. Binomial, you want to expand, so it's binomial expansion formula. Let's take a look at the MF26. Let me just find my MF26 first. Where did I put it? Hey, I didn't download it. Oh, I didn't download it. Oops, that's not good. Okay, let me just okay, give me a second. I need to download the MF26. Hold on a second.
Okay.
Or you can open up on your end as well if you have it. Just Google for it.
Okay. So I don't like write out the n choose 1, the n choose 2.
You can, if it helps you, but usually most people are extremely familiar with binomial expansion already and they don't need to write it. They know that it's 1331. I mean, most people know it.
Oh, okay.
Yeah. Okay. How do I get it to display? I want to annotate on this. Wait a minute. Sorry.
Okay.
Go here, go here. I don't want this. Remove this. Download. Oh, this bad. Sorry. Okay. Okay. Okay, MF26, finally. Okay, let's take a look at the MF26. So over here in MF26, you want to use the binomial expansion formula. It is provided at the bottom over here. Okay, binomial expansion. This is the formula. Let's see how we can use it. Let me just take a screenshot. Then I'll move over to the next screen. Okay, how do we use it? Let's take a look. Okay, I need more space, so I'm going to shrink it down now. So we eventually need to get the answer a cubed plus 3a squared bi minus 3ab squared minus b cubed I. So this one requires a bit of work. Let's see how we can get that. So we start off with the numerator a plus ib power 3. So how to use the formula? Is it too small?
Okay, can see. So
Yeah.
it's a cube
Yes, you start off with a cubed plus
a square b.
hold on.
A
No. N choose one. Must write down. I think for you need to write down.
Okay.
So N is
3.
3, choose 1. By the way, there's an invisible 3, choose 0 at the front, but the formula never uses us. 3, choose 0 is just 1, by the way. So you don't need to write down. And there's also invisible, maybe I'll write down the invisible ones in black. B power 0 and N choose 0 or 3 choose 0. It's not in the formula. It's just 1.
Oh, okay.
Then continue the pattern. 0 go to 1 already. What's the next one? A power N minus 1. So what's N minus 1?
A square.
A square, exactly. What's the pattern here? You just minus 1. What's the pattern here? You just plus 1. Then how about here? You have a b power 0. Now it becomes b power
1.
plus 1. So what do you notice about the sum of the powers? This one go down by 1, this one go up by 1. So they will always stay the same, right? 3 plus 0, 3. 2 plus 1, 3. Next one.
Oh, I don't write the I.
Oh, sorry. Okay. Feel like you mentioned this. I made this mistake again. So IB, sorry, it should be a BI and power 1. Over here, it shouldn't be B, it should be a BI or IB power 0. Oops, thank you.
Okay.
Then you continue, next one.
Then
Plus?
is 3 choose 2, then A, then BI square,
Exactly. Good.
then 3 choose 3, then it's just BI cube.
Yes. Or a power 0 to follow the pattern. A power 1. Huh? Then power 0 is just 1. Times 1, you can ignore it. Yeah, so we ignore it. Okay, I'll ignore it by writing a light color highlighter to cancel it off. Okay, let me just delete that. Okay, what was I doing? Yes, I expanded it. So now we try to simplify. Why is 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3? It's just 1, 3, 3, 1. You know how to type in a calculator?
No.
Okay. Let me see how I can do this.
So if I c to the power of 4, I also use this binomial?
Yeah, yes.
Oh.
Yes.
Oh no, okay.
Yeah. Correct. Okay. Now you know. Okay, let me see if I can get my calculator to appear on the same page. Something like this. Wait, need to do a few things. Just make it a little bit bigger. Like this. Okay. Let me just share screen. Share. Can you see my screen?
Yeah, can.
Can you see the GC on the right?
Yeah.
Okay, I think that's a better setup. Okay, easier. Okay, good. Okay, let's move on. So, yeah. Is it lagging a bit?
Yeah, but still okay.
Okay, okay, I'll try to manage the lag. So over here, what we have is these values. You want to calculate the 3 choose 1, 3 choose 0, 3 choose 1, 3 choose 2. Let's see how we can do that. So what you can do, you press math, then you go to probability. Can see,
Okay.
and NPR, NCR, which one? Must be
The NCR.
Number 3. Then you can type in 3 and then right arrows. Oh, sorry, until correct position, then 0. Okay. Then you
Okay.
get 1.
Okay.
And then you repeat. 3 choose 1. You get a 3. Repeat. 3 choose 2. You get a 3. 3 choose 3. You get a predict. What is it?
1.
1, exactly. Of course, you can also use a GC. Yeah. I mean, you can also use a scientific calculator.
Mm.
Let me. Where is my scientific calculator? Can see my scientific calculator?
Okay.
Okay, good. So, oops, let me just bring up to the original page. Of course, you can also do this 3-second shift, then NCR here, or the yellow color one. And then you choose 0 equals. Then let's say you don't press the on button, you press the left button. You'll get back to the same value. You can press delete and change to 1 equals 3. And press the left button to recycle the working, then press delete backspace and choose 2. You get 3. Change it, delete, choose 3, you get 1. Okay, then you can press up to see the history. Okay?
Okay.
Yeah. All right. Let's just bring back up the calculator. Okay. Oh no. I need to minimize this. Okay. Yeah. Okay, let's just minimize this. Better. Oh, go away. Okay, I'll bring up the GC later. So let's continue. Yeah, that's how you calculate it. You basically get 1331. So I'm just gonna quickly replace this. 1, 3, 3, and then 1. Okay, so simplifying, we get what? 1 times a cube, 3 times a square, but multiplied by bi. Then 3 times a, then bi square. Here, maybe you can work it out at the side. What's bi square? B square I square, which is
Negative b.
square. Okay, negative
Yeah.
b square. Then negative in front, so change the plus to a minus. Don't forget the 3a, then b square. No more i's, because I square become a negative 1. Yep. Then you add on 1 times of a times a power 0, which is 1 times 1 times bi cube, which is b cube I cube. What's I cube?
1.
No.
Negative. Wait. Negative I.
Yes, negative I. Oh, it's I square times I, so negative 1 times I, which is minus I. So simplifying what we get, this one, I'm just gonna skip a step. I cube immediately replaced with a I, but then the plus sign replaced with a minus. Okay. Clear?
Yeah.
Can okay, good. Then after that, you just combine the like terms, which is exactly what you get as the answer over here. As the answer over here, this is the real part, and then there's the imaginary part. Can see?
Yeah.
Maybe I highlighted then it'll be clearer. A cube is the real part, minus 3ab square is the real part as well. So it's over here, like blue, and the imaginary part is 3a square bi, and minus b cube I, so 3a square b minus b cube I. Then don't forget the denominator lah. Then you have to write on both fractions. Is that clear?
Yeah.
Okay, good. Then after that, you can okay, read back the question. I can't remember already. What did they say? They said that this fellow, w square over w star, which we so painstakingly found, is purely imaginary. Means what? Which part is 0? This or that?
The right side.
That part is 0, the imaginary part. Okay, so that means that
wait. No, it's the real one.
The left one. Correct. Oh, trick me. You're trying to trick me? Okay, no.
No.
I got confused myself. Sorry. Yeah, purely imaginary means that there is no real part. So the real one is equal to 0. So that means that we get this fraction equal to 0. Is that okay?
Yeah.
Can. Sorry, I got confused. Okay, yep. Then after that, you just need to multiply a square plus b square over 0 times anything. Just disappears, becomes a 0. Then you're left with the numerator equal to 0. Factor out the a, then you get, okay, they skip a few steps. Factor out the a, you get a square minus 3b square. Here, 3b square, do you realize that it's actually just the same as a square minus something square? What's inside the bracket? It's really just square root of 3, then square root of b square, which is b. Can you see that?
Oh.
Can so a square minus b square, how to factorize? A minus b, oops. Bracket, then a plus b. Is that okay?
Yeah.
Can Okay, good. Then after that, you got 3 factors equal to 0. Something multiplied by a second thing, multiplied by a third thing equal to 0. First guy equals 0, second guy equals 0, or third guy equals 0. Then you just solve for, then you bring the minus over, so it becomes a positive. Bring the plus over, becomes a negative. Okay?
Okay.
Then we're not done yet, because now what did they actually ask you to do? Find the possible values of w in terms of a. So we don't want any b's, we want a's only. We want a's only. Actually, I think it's better if I just change back to my iPad screen. Okay, Ken. So now we want to find out this expression, this entire expression, which is w square over w star, in terms of a. In terms of a. Since we know this is purely imaginary, which part can we just ignore straight away?
The real part. The left part.
The left part can just ignore straight away. You don't even need to try to look at it. You don't even need to look at it. Just focus on the right side. So it is purely imaginary. That means that we just need to take this expression and, oh wait, are they asking for w or w star? Oh, they're asking for w. Sorry. No. Can I try again?
Yeah.
So we don't talk about the ignoring part. Sorry, I thought they were asking for W squared over W star. No, they're asking for W. I read the question wrongly. It should actually be W equal A plus IB. Then you want to solve it in terms of A. So we need to get rid of the B. Substitute the B with something in terms of A. Does that make sense?
Yeah.
That's the goal. So because of that, because we need to replace the B with A, that's why over here solving for A is not good enough. We need to make B the subject. We need to make B the subject. Is that clear to you?
Oh, yeah.
So if not, you might be confused why we make B the subject. So now we got B as a subject, then we can replace into the formula. Okay, A plus BI or I times B, right? Then the B, they did a shortcut, they just put down plus minus. You can write it separately. Do you know what I mean by separately? Like instead of plus minus, you can just write down A plus I times the positive version. Positive version of 1 over square root 3i, A, and the negative 1 over square root 3a. Oh, this one they are just taking a shortcut. Okay. Then that's the answer. There's an alternate solution, which is, okay, here's how they do it. Let's just copy down the question in case you forget. And then I'll paste it at the bottom. Okay, go a bit faster. Yeah, so here what they did is they take W equals to A plus BI. Then they use the exponential form. I think you forgot about exponential form or you didn't read the question carefully in one of them. They asked for a convert into exponential form, but you didn't do it. But then I see that later on you suddenly remember you can do this idea. So the alternate solution here is W is equal to A plus IB, you equate it to REI theta, where the R is the length of the, or the, how do I say this? The magnitude of the complex number, which is square root A square plus B square. And then the angle is tangent theta equals to B over A. This part, whenever you have a arbitrary A and B, right, for all practical purposes, you can just say that tangent theta is B over A. Don't need to care about plus or minus.
Oh, okay.
Can that's only when you have an unknown A, unknown B. But usually, if you are dealing with actual numbers, like positive square root 2 minus away I times 7, then got plus, got minus, got actual numbers. When you're trying to work out the theta, please follow the logic that I told you. Draw a diagram, draw the alpha, draw the theta. That kind of thing. Okay, can Yeah, so for practical purposes, you just put down B over A is good enough. So what we want to find, W square over W star. So it's really just R square times E power I2 theta. Are you aware of this? You just need to square both sides.
Yeah.
I mean, square both of the factors, right? R squared and EI theta square. Then whenever you square an exponential, you just multiply. So I theta times 2 or I2 theta. Then how about the denominator, W star? It will just be REI negative theta, right? REI negative theta. Then in this case, why is it negative?
Because the conjugate.
Argument W star equals to negative of argument W. I explained to you briefly before, it's just a reflection. If there's my positive theta, at the bottom will be my negative theta. So that's why W star has a minus, because you're going in the opposite direction. Okay, so that's why there's a minus theta here. And then how do you simplify this? R squared divided by R is really just R. Then EI2 theta divided by EI negative theta, you just have to subtract the negative theta. Negative theta bring up become plus theta, so you get 3 theta. Is that okay?
Yeah.
Let's bring up become plus. Okay, then after that, they tell you this is purely imaginary. So how do you deal with it? How did they get this conclusion? What's going
on?
That's when you need to convert from exponential form into x plus iy form. And then once you know it's x plus iy, let's say you know it's x plus iy, you found out what's x, found out what is y. I'll explain later. They tell you that it is purely imaginary. So which part is equal to 0? Is it the x or the y?
The x.
The x equals to 0. Okay, so now so we got this already. now our goal is to figure out how do we find the x and how does it link to this 3 theta. Okay, got pi. When you see pi, you see theta, you must immediately think of the other form. This one is Cartesian form, this one exponential form. What's the last one? Remember, complex number got 3 formats.
The cosine, the sine, that one.
Yeah, trigo format, trigonometry form, trigonometrical form. Yes. So EI theta is equal to cosine what? Let's say we have EI theta equals to
The cosine theta plus I sine theta.
correct. Well done. Okay, then if this theta changes into anything else, let's say alpha, you follow accordingly. If let's say alpha is 3 theta, then it's just cosine 3 theta plus I sine 3 theta. Is that clear?
Yeah.
Okay, then we're going to use that. So over here, we have R, E, I theta, R. The R is being multiplied by an E, so it's a pair of brackets. So that means we actually got R multiplied by the entire expression. I'll use square brackets. So you can see straight away, if I distribute the R, I will get my real part, the X, plus I times R sine 3 theta, the imaginary part. Can you see that?
Yeah.
X plus IY. Okay, very good. Then what do we want again? Make which part equal to 0? Purely imaginary.
The cosine 3 theta.
The real part must be equal to 0. Technically, okay, the notation should be RE open bracket W square over W star equals to 0. So that means this part equals to 0. Now, the R, you can assume that it's not 0. Okay, so how do you make sure this is equal to 0 if R is not 0? The cosine 3 theta must be equal to 0. Oh?
Yeah.
Then how do you solve this equation? Cosine 3 theta equals 0. Okay, can I just give a quick crash course on solving trigo equations?
Yeah.
I will take around 20 minutes.
Okay.
Let's go. Yeah, because you need that. I think you forgot a lot already. Okay.
Yeah.
Crash course solving trigo equations. Okay, first question. Let's say you have wait, I think I wrote down a summary of the types of questions if I can find it first. Hold on a second. Sorry. Where was that list? Okay. Okay, just copy this down. Wrong one. This one. Yes. Okay, we're gonna deal with 4 types of questions. Okay, 4 types of questions. That's all you need to know to solve trigo equations. Let's begin. So first one, question 1, we're gonna look at let's say cosine of x squared multiplied by sine x times cosine of x equals to, let's say, 1 over 3. We are gonna solve for x for all angles of x in radians. How? First step, anything special that strikes out to you?
The sine x cosine x.
So anything that repeats?
The cosine.
Cosine x. So what can you do? First step is factorize, equate each factor to 0. So cosine x repeats, so we can factor out. What are you left with? Cosine x minus sine x. Clear?
Yeah.
Okay, sorry, I changed the question. I'll change the question halfway. How can? I changed to 0. Okay, then what happens? You got something multiplied by something equals to 0. What times what gives you 0?
Like something times 0.
Yes, correct. So that means it's either this guy equal to 0 and the other guy is anything else, or that guy is 0 and the other guy is anything else. In logic, we would say it's first guy equals to 0, logical, or if you did a bit of programming, it will be but you don't need that. I just make sure you write down the R when you're solving math equations.
Mhm.
The first guy equals to 0 or the second guy equals to 0. Then how to solve? This one, cosine x equal to sine x. Let's deal with this first. Bring the sine x over, you get positive sine x. Then what happens? Wow, so difficult. You can use GC, sine x, and then cosine x, but very difficult to solve. What we need to use now is a special identity. Do you remember what is sine x over cosine x?
Tangent.
I bring down, so it's equal to 1. I divide by cosine x, and then I swap. Yes, correct. It is a tangent x. Yes. Now you got this equation. Let's solve this equation. It's easier to solve. Tangent of x equal to 1. How do you solve it? What you need to remember is how the tangent graph looks. Please remember how the tangent graph looks. Okay, like this. Let me just duplicate this a few times. Whoop. Whoop. One more on the left. Yeah, don't need so many. You get the idea. Okay, this is 90 degrees. I say x equals pi by 2. This one is, distance is 180 degrees or pi radians. So this one will be 3 pi by 2. So on so far. You just have to minus 180, minus 180, plus 180, plus 180. Can you remember? Okay, that's just the tangent graph. And then what that means you have drawn a y1 equals tangent x. Now, how do you solve the equation? You need the right hand side equals to a y2. That's a y equal to 1. So we draw y equal to 1 over here. That's y equal to 1. Where's the solutions? Here, 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 everywhere. Oh, can you see or not? So let's just find the smallest one, this guy, the one that's closest to the origin. How do you find that? You just need to use GC. Use calculator tangent inverse. So alpha, that's your alpha actually. It will be tangent inverse of 1. That's a 45 degrees. Pi by 4. Is that clear?
Yeah.
I think so. Am I wrong? I might be wrong. Let me just double check. Yeah, I'm correct. Okay. Can so once we found that, how do we find all the other solutions? What do you notice? What's the distance between the 2 points here?
The pi.
Exactly, it's pi. How about the other one? Also pi. The other one? Also pi. So every single point, they are just differing by a multiple of pi. How do we represent the general solution for this now? So x equals to pi by 4, but you add on k pi, where k is an element of integers. Integer here can mean 0, 1, 2, 3. It can also mean -1, -2, -3. Do you know what this means if I add on k pi?
Yeah.
It means I add on, if k is -3, it means I start off here, then I jump 3 steps to the left. If k here is a +1, it means I jump 1 step to the right. If k here is a 0, it means I just stay on its own, pi by 4. If k here is a 2, it means I take 2 steps to the right. I start with alpha, I jump 1, 2. So I get the other solution here. Okay? So that's a general solution. Can you understand this idea?
Can.
Okay, good. That is for tangent. Now let's move on to cosine x equal to 0. How to solve? If you try to take cosine inverse, you may end up getting something that is a bit funny, 1.57. What is that? How do you get the exact answer for this?
Times the 180 over pi.
Okay. Wow, okay, I didn't think of that, but yes, that actually works. But usually how I do it is I memorize the cosine graph or use the GC to draw it if you really cannot remember. This is from O-level Emacs. Okay, so what we do is you must remember cosine, it goes down, down, up, up. Okay?
Yeah.
Yeah, so that's a very bad drawing of the cosine, but okay, I'm just going to use it. Good enough. Oh, Notice that it's symmetrical, left and right. Okay, so what does it mean? Just extra bonus fact, not relevant. If you have cosine of negative theta and you have cosine of theta, if here is theta, there will be negative theta. What do you notice about their values?
So
They are the
same.
same. So that's why they are equal.
Oh,
Okay, because it's symmetrical. Okay, just a bonus fact. You should know this identity. You need to know this later. Then how? Okay, let me just erase this. Wait. Actually, no, I'll just leave it. I'll just try and solve this again at the bottom with a cleaned up version of this graph. So what did I want to say? I want to ask you, how do you solve this equation? What does it mean in terms of a graphical approach to solve this equation? Left-hand side, draw a graph, right? How about the right-hand side? You also draw a graph. So it's y equals 0. What's that?
the intercept, like you're trying to find the intercept.
Which
X.
axis is this? This is it's y equals 0 means the x-axis. It's the equation of the x-axis. Okay, so if I just highlight it, this is equal to this guy. That is equal to that guy. Then you want to find the intersection. Yes, which is really just the x-intercept. Correct. Then now you just need to solve. So how to solve? You just need to know the graph. In this case, you need to understand that it goes in multiples of 90 degrees. Down, down, up, up. 90, 90, 90, 90. Or rather, in radians, it's pi by 2, pi by 2, pi by 2, pi by 2. Also, here is a 90 degrees or pi by 2. Here is another 90, so it's 180 degrees, so it's pi. Here it will be 3 pi by 2, and there it will be 2 pi. It just keeps going up. The cosine curve just keeps going. Okay, then in this case, what do you notice? Where's the intersection? Over here and there. So what's your answer? And there, and there. So let's try to find a pattern. Can you see a pattern?
Yeah.
They are all equally distant, right? Equally spaced. What's the distance though? Remember, it's symmetrical. If here is positive pi by 2, there will be negative pi by 2. So what's the distance here in between negative pi by 2 and pi by 2?
Pi.
Big minus small. It's just pi, exactly. Hey, wait, let me think a bit. Yeah, correct. It's just pi. Of course, you can also calculate it like this. 3 pi by 2 minus pi by 2. Then you get a pi. Or you can think of it in terms of degrees. I think it will be easier. Here's remember, it's 90, 90, 90, 90. So here's a 90, there's a 90. All together is 90 plus 90, 180, which is pi. Right? Can So let's just start with the one that is positive and closest to the origin. In this case, pi by 2. So that means x equals to pi by 2. How do you reach all the other solutions? Plus, take one step of pi, take 2 steps of pi. One step of pi, 2 steps.
So it's also k pi.
Exactly, yes. For this question, it is plus k times pi. Good. Okay, that's the answer. K, an element of natural number. Understand?
Yeah.
Okay, good. Let's try our next question. This is question 1. Next one, we want to use identities. So let's say question 2 here, I have sine square x plus cosine square x plus 2 sine x cosine x. Or maybe I make your life difficult. I write down sine 2x. And then it's equals to, I don't know, let's say, which one have I not used yet? Cosecant of x. How to solve?
Is it use identity?
Use identity. Yes, that's point number 2. Okay, maybe I should bring down my pointers here. Yes, we are currently in our mind map, our concept map. We are at goal number 2. We're gonna use identities. And maybe we'll convert into quadratic equation, maybe not. In this case, let's just expand. You need to know double angle. This becomes 2 sine x cosine x. Agree or not?
Yeah.
So just copy and paste the entire equation, but replace the sine 2x with 2 sine x cos x. So in this case, do you notice something else? What happens to the left-hand side? A squared plus B squared plus 2AB. Does it sound familiar?
Yeah.
Okay, good. Let me see. Actually, maybe it's not. Maybe you could factorize it as sine x plus cosine x. And then you bracket square equals to cosecant x. But that is not so good. Not so good. This is a bit difficult to solve. So what I recommend instead is to focus on sine square plus cos square. What do you notice about these two?
It's 1.
It's 1, exactly. So we're going to replace it with 1 plus 2 sine x cosine x. Then what about cosecant? Do you remember what is cosecant?
It's 1 over sine.
It's 1 over sine. Very good. Then how do you solve this now? Fraction. I don't like fraction. What do I do?
Like multiply.
Multiply both sides by sine x, right? So you'll get sine x multiplied by 1 is just sine x. Plus 2 sine x becomes sine square x cosine x. Maybe it would have been smarter if I just left it alone. And then I write down sine x multiplied by 1 plus 2 sine x equal to 1. Now how to solve? Oh, to be honest, I'm also not too sure how to solve this. Might have made the question a little bit too difficult. It's not a 0. That's a problem. Okay. So sorry. Let me try and change the question. I am so sorry. This is a badly planned question. I'm coming up with it on the spot. Let's just start with our 0. Then we'll end up with a 0. Now it's easier to solve. Maybe over here, it would have also been smarter if I did not expand this part, since it's equal to 0. It's better to keep it as sine 2x.
Yeah.
Huh? So it means, sorry, we don't even convert this into 2 sine x cos x. Just sine 2x is fine. Which means sine 2x is equal to -1. No. Sorry, I brought the 1 over. Okay. How to solve this one?
Can plot graph.
Plot graph, exactly. So what we're going to do is we're going to plot the graph of sine x. Okay, let me just bring this down. Plot a graph. So here's how a normal sine x graph will look. But what do you know about sine of 2x? When you times 2 to it, what happens? Horizontal scaling. Does it get halved or does it get times 2?
It gets half.
Get halved, yes, exactly. So that means that one full cycle, is it from 0 to 2 pi or 0 to pi?
0 to pi.
Pi only. Okay, good. Then that means that we can now try to solve this. This is y equal to sine 2x. And then you got -1, so you want to draw the graph of -1. Y equals -1, let's just draw it in. Maybe my graph is not that nice. Let me try again. I need to make it hit the horizontal lines so it's easier to understand. Okay, maybe I'll draw a few more. Okay, so -1 is actually where? It's actually over here. Do you realize that?
Yeah.
It hits all of the bottoms of the sine x. Then what's the corresponding x value? Let's say for this one. 90, 90, 90, 90. So here is 90, times 3, 270. In terms of radius, it's
3 pi over 2.
exactly. Then how do we get to the next one? How do we get to the next one?
Like k pi.
Here you have to be careful.
Oh,
In this case, because it is 2x, that's why it's k pi. Here it will be a 2 pi, because one full cycle is pi. Then that means that the distance from one point to another point is pi. So likewise over here is also pi. So you have to add on k times of pi. So let's just conclude. So x equal to 3 pi over 2 plus k pi, and that's your answer. K an element of integers. Sorry, must write this down. Is that okay? Let's try another example. It's taking a long time. Let's say now we have, this is question 3, quadratic equation. Let's say you got I don't know, let me think a bit. Let me plan a bit. If I want x minus 3 times x plus 1. Okay. 1 plus 1. Let's say I want positive 1. Yes, correct. Then let's say, yeah, I'll get what? I'll get x squared minus 3 plus 1 is minus 2x minus 3. Okay, let's say we got sine of 3. Okay, no, not sine of 3x. Let's say, let me think a bit. Just sine x is fine. Let's say we have sine of x squared minus away 2 times of sine x plus 3, minus 3. Is that minus 3? Yeah, minus 3 equals to 0. How to solve this equation?
Is it quadratic?
Yes, that's the hint here. Do you see the pattern?
Yeah.
You can let's say let y equals to sine x. What happens?
So it becomes y squared plus minus y
Minus
3.
2y minus 3. Factorize, we get y minus 3y plus 1. Then you solve. You get y equals to 3 or y equals negative 1. Correct?
Yeah.
Okay, good. Then what's y? We're not solving for y, we're solving for x. So we replace the y with
X.
No?
Sine x.
Sine x, yes. So sine x equals to 3, sine x equals negative 1. What do you know about the left-hand side? Equals to 3. Draw a graph. Straight away, I think you can tell. I hope.
Huh?
No solution.
How? Oh,
Maximum value of sine is what? 1.
1.
Minimum value is what? Negative 1. Likewise for cosine, by the way.
so is this the principal
Maximum of 1.
value?
Negative 1. Principal value? Oh, principal value. No. Principal value is talking about this region here.
Oh, so do I still need to know this for A levels?
Yes.
Oh, okay.
Everything from A-Max is assumed knowledge in A levels.
Huh? Oh, okay. But I don't see where to use it.
Yeah, here. Okay, actually, now, honestly, do you really need to use it? Is there a direct application? Not so much. Honestly. Okay, but basically, you just need to know that it's from the domain. It's restricting the domain such that you can get a graph that is 1 to 1. You know what's 1 to 1?
Oh, yeah.
Right, it passes the horizontal line test. Each horizontal line only cuts 1 time. It also passes vertical line test because it's a function. Only cuts 1 time. Okay. Then likewise for cosine, cosine basically this is basically from negative pi by 2 to pi by 2. Oh. Yeah, so this is the principal values. Then the principal range is -1 to +1. Maximum and minimum value. It's all basically the you need to know this. I think it's quite easy to understand. I'll just quickly explain this. Cosine looks like this. I didn't explain how sine looks like the top one and cosine looks like the bottom one. I hope you get that.
Yeah.
The cosine one in this case it will be this range here. Okay, do you see it's 1 to 1?
Yeah.
So it's from 0 to pi by 2. The principal range. And likewise for tangent, if I quickly draw it, the There's is it sorry, no, this is not pi by 2, this is pi. Sorry. It should be pi. Right? Pi then 90, 90, 90, 90. So this one here is 180 degrees. Okay, then this one is at negative pi by 2, at another negative pi by 2. You got asymptote, so it's very close but never touching, but then it goes closer towards the origin, and then it slowly increases until, and then it suddenly speeds up. And then you repeat. Like this. And just keep repeating. Then which part of the graph do you see that's closest to the origin and still can get the full curve 1-to-1? Which of these curves, let me draw a few more, is closest to the origin?
The middle one.
The middle one. Okay, so we're gonna focus on this middle one. We want to make sure our function is this guy only and we ignore the rest. So that is 1-to-1. Then that must mean your box must be here. So the principal angle must be x equal negative pi by 2 to x equal positive pi by 2. Then the principal range, it will just be from negative infinity to positive infinity. It goes forever. Okay. This is the picture you should remember from O levels. No? This one, and this one?
Yeah.
Can yeah, not honestly not so relevant. Okay, can kind of ignore it. But now here, what you do need to remember is that there's a maximum of 1, minimum of -1. So when you try to solve its equation, you're essentially solving simultaneous equation. Y equals sin x on the left, y equals to 3 on the right. So where's y equal to 3? It's somewhere on top of this graph. So this is y equals to 3. Do they intersect at all?
No.
So do you think there's a solution?
No.
So x has no solution. Okay, that's for the first equation. How about the second equation, sin x equals -1? No space. Let me just try and squeeze the working.
Half is like at the bottom.
Yes. We already solved it just now. But
Yeah.
just now it was for 2x. Now we try with sine of 1x. So how do we do that? Draw a graph again. Okay, so where's -1? Over here, y equals -1. Intersect here, intersect here. Tell me what's the angle here, here. When it's a 1x. Multiples of?
2 pi.
No, sorry. I meant, what is this angle here, and here? Can you tell me what those angles are?
Like 90, 180, then 270, then 360.
Correct, yes. In radians, it will be pi by 2, pi, 3 pi by 2, and 2 pi. So what's the angle here?
3 pi over 2.
270 degrees. How about this one here? 90, 90, 90, 90. Is it because I'm drawing the graph too uglily? That's why you cannot understand.
Okay.
Ayo. Something like that, So what's this angle here? What's the distance between them? Is it pi? 90, 90, 90, 90.
2 pi.
Exactly, it's 2 pi. It's not pi anymore. That's what I'm trying to bring up here. Just now it was pi. Okay, maybe I should have drawn the distance here. The distance here is pi. But now the distance here is not pi anymore.
It's
now it was
2
pi. Now it's 2 pi. Exactly. 2 pi. So of course you can just keep drawing many graphs, and then you just realize it's multiples of 2 pi. Multiples of 2 pi. To the left and to the right. So in general, it will just be 3 pi by 2, x equals 3 pi by 2 plus k times of
2 pi.
2 pi, exactly. Then k an element of natural number. Oh, sorry, integers. In this case, you just put down a plus, always put down a plus. Because the k here element of integers can consider the negative numbers as well. So you just put plus is okay already. K can be negative.
Oh, okay.
Then sometimes in solutions, you also see 2k pi. They'll just swap the order around. I don't think you'll be confused. Are you confused by that? I don't know. 2k pi. Sometimes they write that.
So if it's in a question, do they want to see my graph?
No lah. No, they just want the solution.
Okay.
Okay, just make sure you get the correct multiple. So go back to the answer, back to the solution. Wait, actually, is that all that I need to talk about? Let me see. Look at my plan again. Right. Yes, I talked about it already. Just now, I have a sin x equal to 3, right? Means that no solution because the graphs don't intersect. How about if I have like sin x or maybe cosine x equals to negative 100? Can you solve this? Or what's your answer? Draw a graph again. Cosine x here. Maximum and minimum is
but cannot is
1 and negative 1. So therefore, y equals negative 100 is at the bottom. So therefore, your answer should be
0.
no,
Undefined.
No solution. Just say x has no solution.
Oh, okay.
Or just write no solution can already. No solution. That's all. Okay. Undefined is also okay. Can I understand this? Maximum of cosine and minimum of cosine. Likewise for sine and cosine. For both sine and cosine, they have a maximum and minimum of positive 1 and negative 1. However, for tangent, is there such a restriction?
No.
No, it goes on forever. Okay.
Yeah.
So that's why there won't be such restriction. I wrote down these cases here. Oh, right. Negative 1 covered already. 1 also covered already, I think. Then how about 0? Did I cover that case? I think I did, right? Cosine x equal to 0. Right, it's the same thing. You can do the same situation if it's sine x equal to 0. Just draw the graph of sine x, draw y equals to 0, which is x-axis, and find the points of intersection. Can? Understand? So let's summarize. First, you factorize, then you equate each factor to 0. That's this kind of question. Then next one is to use identities. So for example, you can use sine square x plus cos square x equal to 1. Then you substitute with a 1, that kind of thing. Then sometimes you also get quadratic equation. Over here, I say substitution required. It's the one where we substitute with sine x. Right, over here, sine square plus cos square becomes a 1. That's using identities. Then here you do a substitution, y equal to sine x, then you get a quadratic equation. Blah, blah, blah. You know this, right? Remember this? Yeah, that's question 3. Then the next question I talked about is equal to extreme values. Inverse trigo is not advised. The recommendation is to draw a graph. I strongly recommend you to draw a quick graph. Like if you have sine x equals negative 1, sine x equals 0, or sine x equals to positive 1. Basically, these 3 extreme values. Likewise for cosine x, negative 1, 0, or 1. And you should just draw a graph. Then here I wrote it a bit abstractly. I said k sine x equal to k, then k less than negative 1 or k more than 1. So for example, if k is negative 100, the k is for both sine and cosine, or positive 1000 or 1 million. Straight away you should reject, say no solution, because it exceeds the negative 1 to positive 1 region. Can? Then that's all for crash course on trigo equation. 34 minutes. Okay, let's go back. Now we can answer the question. What was the question already? Sorry, let me drink some water.
Okay.
Here, question did we go through already? Oh no, I forgot. Question 7. 7 done already. Question 8. Or is it 7? Let me think. Did we go through question 7? Incomplete. Yes, we stop here. Okay, yeah. So what we have w square over w star and is equal to re I 3 theta. They tell you it is purely imaginary, which means that the real part must be 0. If the real part is 0, then if I expand it in trigo form, what you realize is this is the real part, r cos 3 theta, equate to 0. We will assume that r is not 0. If not, this will be a very boring question. 0 times ei theta is just 0, so w equals to 0. I doubt that's what they're asking. Okay, we can ignore that case. So r is not 0. Yeah, if it's 0, then there's not much to do. W square over W star also 0 square over W star. Then it's just 0 lah. Everything is 0, not important. But so let's assume r is not 0. Then that means that cosine 3 theta must be 0. Right? R times cos 3 theta. This is not 0. The other guy must be a 0. So cosine 3 theta equals 0. This one how to solve? Now you're ready to solve. How to solve? Cosine 3 theta equals 0.
Or draw graph.
Draw graph, exactly. Good. 30 minutes well spent. You can say the 2 words, draw graph. So draw a graph, I'll draw for you cosine. Then when you have 3 theta, you get squished 3 times, right? Or 1/3, you get scaled by 1/3 along the horizontal, parallel to the horizontal axis. Then in that case, here, would it still be 2 pi?
No.
It'll be 2 pi divided by
Over 3.
3. Exactly. Everything else also divided by 3. So maybe if you can just let me list them all down. This is pi by 2 divided by 3. So times 3 at the denominator. Here is pi divided by 3. Here is 3 pi by 2 divided by 3. So times 3 at the denominator. So on and so forth. Oh. So let's simplify this. This is really just pi, no space. Let me increase the size a bit. Hold on a second. Yeah, so let's just label this. This will be pi by 6, pi by 3, 3 pi by 2 over 3 pi by 2, then times 3. The 3 cancel off, you're left with pi by 2. This guy 2 pi by 3 is just 2 pi by 3. So let's list out the angles. We got pi by 6, pi by 3, pi by 2, 2 pi by 3. Can you tell me where are my intersections with y equals 0? It's here.
The pi over 6 and the pi over 2.
Very good. Okay, so here. Okay. And of course, you can see the other guy by symmetry will be negative pi by 2 lah. Sorry, negative pi by, what is it? Pi by
6.
6. Very good. Yes. And then the other guy will be, tell me.
Negative pi over 2.
Exactly. Okay, so what's the distance? If you want to have the general solution, we start off with, I prefer, I like positive numbers and I like small numbers. So over here, this is the only one that satisfies my requirement. You see that?
Yeah.
Negative, I don't like, very scary. I will make careless mistake with negative. How about all the positive? I like to pick the smallest one. So I pick the smallest one. I don't even look at these. These are not relevant. We only look at the ones that intersect the x-axis because it's equal to 0. So which one I pick? I pick pi by 6. Then I consider from pi by 6, how do I reach all my other neighbors? If this is my home, then I want to travel to Changi Jewel. I want to travel to Jurong Point. Or I travel to any other places. I need to take a few MRT stations. How many? What's the distance between each station? What's the distance?
2.
Huh?
2. Is it 2 pi over 3?
Let's calculate that. So what would it be, the distance over here? It will be pi by 2 minus pi by 6, half minus 1/6. That's, I need a calculator for this. What was your answer again?
1/3.
1/3. Very good. So let's just double check. Negative pi by 6, you plus 1/3 of pi. Do you get back to pi by 6?
Yes.
Very good. Then confirm correct already. The distance here will always be the same. It will be pi by 3, which is, if just to make it easier on your brain, it's 60 degrees. Right? Okay.
Yeah.
And what do you realize? It's really just if you start with the original cosine graph, maybe an easier way to do this is to realize that this is pi by 2, this is 3 pi by 2, the distance here is pi. But you just have to divide by 3. Why? Because now we went from y equal cosine x to cosine 3x. cosine 3x. Okay, then you just need to divide by 3. That's why that's this. Because of the horizontal scaling. Is that okay?
Yeah.
Can also pi by 3, but we will take multiple steps of pi by 3. So what do we do with this pi by 3? We have to add, multiply by
K.
K. So you start with pi by 6, then plus
K pi over 3.
K times of pi by 3. Exactly. Okay. That's exactly what they have over here. Understand now?
Yeah.
Okay, good. Can then now how do you get these these three answers? You just substitute with different values of K. This one is K equal to 0. This one is K equals to 1. This one is K equals to -1. Okay. Yeah, you usually pick values that are in this format. You start with K equal to 0. Then after that, you put +1. Then you choose -1. Then you choose +2. Then you choose -2. Then you choose +3. Then you choose -3. Depending on how many solutions you need. Here, we need 3. Why? Because we started off with 3 theta. You are quite likely to have 3 solutions when you have 3 theta. Yeah, that's the usual pattern. So now we solve for the theta. Then what do? We just use this formula here. Tangent theta equal P over A. Then we just have to sub in the theta with those possible values. What you realize is that in either of these cases, you either get 1 over square root 3 or -1 over square root 3. Do you understand why?
Why?
Okay, let's see. So if theta equals to pi by 6, tangent theta means what? Tangent pi by 6, you will get 1 over square root 3. Okay, tangent 30 degrees is 1 over square root 3. That's the case 1. This is the K equal to 0 case. K equal to 0. Then the next one, you just sub in again. So K equals to +1, you will get theta equals to, you just sub in the K with 1. You can check it on your own. You will get a pi by 2, right? Okay, then after that, you just take tangent of theta, which is tangent of pi by 2. What's tangent of pi by 2? Pi by 2 is 90 degrees. Infinity. So there is no solution.
Oh.
So we ignore this case. Then we move on. K equal -1. We get theta equals to -pi by 6. Right? You just substitute the K here with -1. You get -pi by 6. Can? Okay, then you take the tangent of theta. It's tangent of -pi by 6. Do you know that tangent of -pi by 6 is the same as negative tangent pi by 6? Recall. Can you tell me what's the formula for these three? Also from O-level AMAX.
Sine theta.
Is it just sine theta?
Negative.
Yes. How about the cosine?
It's cosine theta.
Don't need negative in front? Do you need?
Don't need.
Negative take out. Why? Why don't need? Because of the symmetry. Just now I explained already, right?
Yeah.
So symmetry, that's why they're the same, even if it's negative. Then tangent, you need the negative. Okay, it's because of how the graph looks. If this is 30 degrees and that's -30 degrees, you get a y value here, which is 1 over square root 3. But over here with -30, you'll get a -1 over square root 3. You just have the extra negative sign because of the anti-symmetry, like DNA, the anti-symmetry shape. Okay, that's why you end up with a -1 over square root 3. So you have an extra negative sign. Same thing with your sine graph. Let's say you got 60 degrees here. Let's say you got a -60 degrees here. Maybe we are not so nice. -60 degrees here, -60 degrees here. Your corresponding y value is √3/2 and a -√3/2. Okay, it's just because of the anti-symmetry property. It's like a DNA anti-symmetry. Then there's positive root 3 over 2 and negative root 3 over 2. That's why there's an extra minus sign here. I just use one example with 60 degrees and minus 60 degrees. Oh. Minus 60 and 60. Okay, good. So now tangent, you take out the negative already. Tangent pi by 6 is what? Tangent of 30 degrees, which is 1 over square root 3. That's how we get a negative 1 over square root 3. These are exact values. You should know this from O-level A max already. Right. Exact values.
Yeah.
Oh, just recall. Okay, so now you got negative 1 over square root 3. That's how you got this one. Just now you had no solution, so we ignore this one. You had a positive 1 over square root 3, so you get this one. That's how you get these two solutions. Clear so far?
Yeah.
Okay, that's how you get these two. So it's actually just b over a. Then you can just times a over b over a equals 1 over square root 3, or b over a equals to negative 1 over square root 3. How do you get b over a? It's from a formula here. Tangent theta equals b over a. Then you get b equals 1 over square root 3a, or b equals negative 1 over square root 3a, which is the same as the previous part. If you remember what I was talking about, I'm just giving an alternate solution, finding out the two b values. Can?
Yeah.
Then you just sub in, and then you get your answer. Okay, that's it for this question. Done? Can?
Can.
A bit challenging. You need to know a lot of things. Trigo, exponentials, solving general equation, simultaneous equations, and all the three forms. Yeah, challenging this question. It's a O-level question. I mean, A-level question, 2015, quite recent as well. So you need to know. Okay, and moving on, let's go to question 8. Question 8. This one correct. This one compare real is okay. Here you make algebra mistake. X times y equal to half. Then you make x a subject by dividing by y. That's okay. That's okay. Then you got y over 2. That is not okay. That's not okay. Half over y is correct, but y over 2 is wrong. That's not equal. It's actually 1 over 2y. Can you see? Half divide by y means half divide by y over 1. Then use Kentucky Fried Chicken or Kentucky Chicken Fried, KCF. Keep the half, like the yellow color. Change the divide to a times. Flip the fraction from y over 1 to 1 over y. Then you get 1 over 2y.
Okay.
Can?
Yeah.
Okay, algebra mistake, then arrow carry forward all the way. That's part 1. Then part 2, never try. Part 2, never try. So I just go through the solution instead. Okay, let's go through. So question 8, let's move on. Question 8 is another A-level question from 2002. When you see N, it means A levels. The complex number x plus iy is such that this guy equals to I. Find the possible values of the real numbers x and y, giving your answers in exact form. So again, doesn't this look familiar? It's just asking you to find the square root, right? This question is really just asking you to solve for x plus iy. Isn't that just plus minus square root of I?
Yeah.
So what they have asked you to do in part 1 is to find an expression for the square root of I. Then later on in part 2, what do you think you're going to do in part 2 in the hence question?
Use the part 1 answer.
So in other words, you need to make use of what? What's this over here? What did I find here in part 1? What will I find here in part
1? Like the answer, like the...
Read it out.
Like I will
plus
find the...
minus the blah, 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 blah.
Oh, plus minus the square root of I.
Yes, plus minus the square root of I. So over here, can you see how it's related to plus minus square root of I? Almost. Got square here, got I here. Why don't we just take the square root on both sides? Plus minus. Can we do that? Can.
Oh.
Can. Why cannot? Yes, you can. Okay. So I'll just solve the part 2 quickly. Later then I explain in detail. So square root negative I, then plus minus. But wait a minute. Square root negative I, isn't that just negative 1 times I?
Yes.
Why do I want to do that? Because I only know from part 1 plus minus what? Square root of what? Square root of what?
So I.
So I need a square root I on its own. How do I go from negative I to just an I on its own?
Oh, must split up the thing to like
Split up
square
as,
root of -1, then times square root of I.
but what square root of -1?
Is I.
Exactly. So it's I times the square root of I. Do we know how to find square root of I? We will find it later, part 1, 4 marks. Then after that, just times I. Then the square root of W squared is just W. Then we're
Oh,
done already, right? Plus minus I multiplied by whatever you get from your answer in part 1. Is that clear now?
yes.
Okay, good. Yeah, actually, maybe it's nicer to phrase it as plus minus I, and then you times, oh, sorry. And then you, yeah, no, I should just leave it alone like that. Okay, then let's just proceed to solve this. So x plus iy square equals to I. You can expand it, you get x squared plus 2xyi plus yi square. Simplify, you get x squared minus y squared, minus because I squared is -1. Then 2xyi you write over here, equals to I. Then you compare real and imaginary, you get x minus y squared equals 0, 2xy equals to 1. Is that clear?
Yeah.
0 plus 1i. Then you can just solve for x and y. How? You can just make one of them the subject. So let's say this guy, you can make it as x equals to 1 over 2y. Then in that case, the equation will become 1 over 2y squared minus y squared equals to 0. Simplify, you get 1 over 4y squared minus y squared equals to 0. Multiply throughout by 4y squared, you get 1 minus 4y power 4 equals to 0. Then you can use a GC. Wait, actually, let's not use a GC. Let's just let me see a bit. Yeah, then you can actually just solve it manually. Here, y power 4 is 1/4. So y is just the 4th root of 1/4. 1/4 is half square. So you raise it to power 1/4. Means half to the power of half, which is the square root of 1/2. Then it becomes square root 1 over square root 2, which is 1 over square root 2. But you need a plus minus. Sorry, I forgot about plus minus. Because you are taking an even. You have an even root here. What I'm doing is I'm taking raised to the, take the 4th root. Then you put a plus minus in front. Okay, can Yeah, that's one way to do it. I think what they did is something slightly different. They started with equation 1. They make y the subject. So minus y squared bring over become positive y squared. So x squared equal to 0 plus y squared. Then you solve for y, take square root on both sides. So you get square root of x squared, which is just an x. But don't forget your plus minus in front. Okay, then after that, oh no, where is my? Okay, then after that, what do you have? You got, if you can just bring up my highlighter. Hold on a second, give me a moment.
Okay.
Give me 1 minute.
Can, sure.
Oh. Can see the laser pointer?
Yeah, can.
Yeah, okay. So what we have here is what they did is y equals plus minus x. How do you get that? X squared minus y squared equals 0. You just take the minus y squared, bring it over to the other side. Then as a result, you get y, what you get? You will get, I'll just annotate it a little bit. So you get x squared equals to y squared. Then how do you solve for y? Plus minus square root of x squared, which will become plus minus x, which is what they have over here. Then how do you solve for the other guy? You just have to sub in the y over here. So it becomes 2x multiplied by our y equals to 1, 2 cases. You have the plus or minus, plus minus x. two cases. So you get 2 times x, which is 2x squared, with plus minus. Then you want to solve for x, or x squared first. You just divide by 2. Then you get 1/2. But then you can also bring the plus minus over. So that's how you get a positive 1/2 or negative 1/2. And for x squared, then now you want to solve for x, you just take square root on both sides. Then you'll just get plus minus 1/2. Okay, which is what I got over here as well. Plus minus square root of 1/2, which is square root 1 over square root 2, which is 1 over square root 2. Then after that, you sub into equation 2. Where's equation 2? It's over here. Then you can solve for y. What does it mean? Oh, what just happened? Oh no. Oh no, oh no, oh no. This is bad. This is bad. Okay, like this. Yes. What was I saying? Yes. I was saying now you want to sub this into 2. The x equal plus minus square root 1/2. So what do you get? You get 2 multiplied by plus minus the square root of 1/2 times y equals to 1. You can just make y the subject by bringing all the other things over. Then you get 1/2 of square root 2 and negative 1/2 of square root 2. Is this okay?
Yeah, can.
These two? Okay, good. I'm going to clear the drawing. Let's scroll down. And in this case, we got the x and the y solved already. So we are essentially done. X equals square root 2 over 2, y equals square root 2 over 2, or the negative version. Yep. Okay, how do I get this to go? Oh, okay, highlight and disappear. Okay, so over here, what we conclude is that z is equal to this guy, or z is equal to that guy. I can show you this and this. Can? Because of the x and y. There's a x, there's a y, there's the other x, there's the other y. Okay, moving on. Now we got w squared equals to negative I. We want to solve for w using part 1. How do we do that? What they did here is something a little bit special. They took the conjugate. Okay. When they take the conjugate, what happens? This is 0 minus I. So conjugate becomes 0 plus I. Right?
Yeah.
Okay, then in that case, yeah, so you take the conjugate, that's why you get a positive I. What's the benefit in doing that? What it means now is that you got a square, you got an I. So if you want to solve, you can solve for W star, which is plus minus square root of I, which we already found. It's over here. Over here and over here. Correct or not? So we can solve for W star, but then later on, we just conjugate that and then we can solve for W. Does it make sense? Okay, so what they did is they replaced x plus iy by W star. Okay, fine. Basically, they just solve for W star. They write down this is the positive, this is the negative square root of Wi, square root of I, and there is the positive square root of I. This is negative, that's the positive. Is that clear?
Yeah.
Yeah, they just bring down. Oh, sorry, wrong direction. Oh no. Oh no. Back. This one go here. And that one go there. Can? Okay, then after that, you just have to solve for W by taking the conjugate. Okay, it's a creative way of doing it. Oh, right. Actually, sorry, did I give you the solution?
I know.
Okay, hold on a second. Pause a while. I'll give you the solution. I think it'll be easier. Then you can just annotate on the solution.
Okay.
If I assume you have an iPad.
I don't have.
Oh. Okay, then never mind. I'll just give it to you so it's easier for you to annotate somehow. I will be sending you my annotations later as well.
Okay.
Let me just send you the file now. Hold on a second. I'm sending on Telegram. Okay, complex numbers. I can just this guy, send over. Okay, yeah. Okay, sent. Nope, not this. Here. Right. Okay, Ken. Let us continue. I think my Apple Pencil is done charging. Okay, Ken, back to the normal state. Okay, then the alternative method, what they did here is that they start off with w squared equal negative I. Then they divide by -1. Okay, they divide by -1. Then -1 is really just I squared, right?
Yeah.
Then you can replace this w squared over I squared as w over I bracket square. But the right hand side, after you bring the minus over, you're just left with I. So you get this. Is that clear?
Yeah.
What is the benefit of doing that? Why do they want to do this? They want to now take the square. Opposite of square is?
Square root.
Square root. Square root, then you can get w over I as your answer. So from using part 1, you're able to get w over I. How do you get w over I? You take the square root. Maybe I'll just write this down. Square root. Then if you take the square root of I, you always need to have a plus minus square root I. But wait, isn't that exactly the same as the answer from part 1? Yes, it is. So you can just copy and paste the answer from part 1. Now you have an extra divide by I. You actually want to solve for W. What do you do with this divide by I?
Can times over.
Times over, then you multiply by I and you get this 2 as your answer. Can you understand this one?
Yeah.
Can all? Okay, good. That's question 8. So again, you notice there's a common trend in all these questions. They always ask you to find square root as an intermediate step. Then later they ask you to hence use the other to find the other solution. Can you see the pattern?
Yeah.
You just need to make sure you get the correct answer in the first part. Then after that, you manipulate the equation they gave you such that you can use whatever you found in part 1, which in this case is what? Which is, can you tell me? Read it out. Read it out.
Plus minus square root I.
Plus minus the square root of I. Now that's the main conclusion you get from part 1. Then you can make sure you also make use of that plus minus square root of I. So you need to make sure the I is on its own. You have a square on the left. That's how you can square root both sides. Then you introduce plus minus square root of I. Okay, that's the main conclusion. That's the main point of this question.
Okay.
Plus minus square root of I from part 1. Use the answer in part 1 to solve part 2. Okay, moving on. Let's look at question 9. What happened here? Question 9 we went through already, but you still made a mistake. I think over here, you use A and B, you recycle the symbol. This is very bad. I think you eventually realize that and you change to alpha and beta.
Yeah.
In a future question. Yeah, this is you shouldn't use A, you shouldn't use B, because you'll get confused. You see, you try to solve for B, but in actual fact, you're solving for the constant here in this factor, which I relabel as a Q. P and Q, you found it, but it's not A and B. You need to use P and Q to solve for A and B. Can you understand?
Yeah, can.
Right. So yeah, the main point is don't save letters. There are many 26 letters you can choose from. Just don't make sure you don't recycle any of the symbols they already used in the question. A, Z, Q, and then here got plus B. Don't use A, don't use B, use something else.
Okay.
Let's look at the solution now. So you got W is given by 1 plus 2i. Find W cube. Okay, this one is nothing. Just use. Did I go through this? Sorry. What do you do in part 1? Oh, right. You manually expanded it over here. This time you got it right. You got -11.
Yeah.
Okay, I don't know. Yeah, so try not to do this. Instead, also presentation, you don't put something times something. You should write down what is that something. It's W square, right? It's W square.
Yes.
Or is it Z square? Let me read the question. It's W square. So you should put down a W square equals. Then here it should be a W cube equals. Can?
Can.
Write that down. Okay, let's just go through the solution now. This one I'm not gonna go through. Just use binomial expansion. You eventually get W cube equals to 1 plus 2i cube, blah blah blah. You get -11 minus 2i. Then part 2, given that W is a root of this equation, find the values of the real numbers A and B. Maybe it's my fault. I never explained last lesson. There is a trick to doing this question, if you remember. Factor theorem, they tell you, like for example, let's say you got x squared minus 1 equals to 0. And this is f of x. They tell you that x equals to 1 is a root. What can you conclude about f of 1?
Is 0.
Is a 0, right? You don't even need to look at the equation. If they tell you x equal to 1 is a root, of f of z equal to 0. F of x equal to 0. Here we just use x. So we be consistent. If they tell you this fact, you can just directly substitute the x with whatever is the root, f of 1. You will get a 0. Right? This is factor theorem. So same thing over here. It's just that instead of having x equal to 1 is a root, we got w is a root, which we know w is 1 plus 2y. So they're telling you 1 plus 2y is a root. All we need to do is to substitute whatever z we see with 1 plus 2i. Does it make sense?
Yeah.
Everywhere that was a z, you replace with 1 plus 2i. Then you just expand. Eventually, you'll simplify into this guy. You can use a calculator, by the way. 1 plus 2i cubed, expand. 1 plus 2i squared, and you multiply by 5, and then you plus 17 times 1 plus 2i. This entire thing can be done using a calculator, and then you plus b. Okay?
Okay.
Can Yeah, then after that you compare real and imaginary part. I actually went through this question before last week already, so I don't want to talk too much about it. Okay, then for part 3, using these a and b values, find all the roots. In this case, that's exactly what you did first. You go and use conjugate root theorem, and then you try to factorize, you get the quadratic, and then after that, using the quadratic, you multiply by a linear, so you can get a cubic. Power 3, here's power 2, so remaining must be a power 1. 2 plus 1 is 3. But here, advice for you to use P and Q, not A and B. Don't recycle the symbol. Compare coefficient, you'll eventually get the correct answer for P and Q. Okay? Can Then you just need to solve this, and then you get your third root. Negative Q over P, which is minus 59 over 27. Okay, then they gave you an alternate solution here. I won't go through this. You can read on your own. Can? Or do you want me to go through? You want me to go through? Okay.
Don't. It's okay.
Yeah, because we are question 10. We are not done. We still got 15 questions to go. Yeah, okay, let's take a look at the question 10 now. Okay. So all the coefficients are real conjugate root theorem. Okay, what happened here? Yeah. Oh, negative 4 here. Then after that, you suddenly forgot to bring down the negative. Can you see? You replace A with 2, but then negative 4, you suddenly just write down a 4. You left out a minus. So error carry forward all the way. C should be equal to 0, not 8. Yeah. Okay. You could solve this question. You could have almost solved this question, but careless mistake. And everything tumble. Okay, then if you manage to get that, you will be able to get not this as a factor. 2x squared plus 8x plus 15 is wrong. It should actually just be x squared minus 1, if I'm not wrong. Let's just read the solution. Question 10. Let's just look at the solution. So over here, they gave you a complex root 1 minus I. So since it's a root, you can do the same trick again. Directly sub in. Don't need to do factor theorem straight away, and conjugate root theorem straight away. You can sub in first and then equate to 0. You'll realize that it will be faster. You'll eventually simplify down to this expression, and then you can solve for k. Do you need me to elaborate on this one?
Don't need.
Don't need, Okay, good. You can solve for k, you get negative 2. So therefore, since the equation has all real coefficients, you know this conjugate root theorem. You get that 1 plus I is also a root. 1 minus I is a root, 1 plus I is also a root. Then that means you can factorize it. And then since this is power 4, you got power 1 here. Remaining power must be 4 minus 1 minus 1, which is a 2. 1 plus 1 plus 2 is a 4. Then in this case, how come in front directly they straight away get a 2x squared? Because in front here, it's a 2x power 4. There's only one way for you to expand this to get a 2x power 4. X times something, x squared gives you x power 4, 2x power 4. There's only one way, it must be a 2 in front. 1x times 2x squared gives you the 2x power 4. Okay, so that's why the coefficient here can be solved. But the linear term and the constant term here, you don't know. So we can use A and B. Oh, they haven't used the letter A and B, so we can use it. Okay, then you just have to expand this. What they did is something a bit funny. They refactored it as x minus I plus I, then x minus I minus I. X minus 1 minus I. This is minus 1 plus I. So you get a plus B and A minus B format. Do you see that?
Yeah.
In general, you can do this in any root. If you have, like, for example, A plus BI as a root, and then by conjugate root theorem, you get A minus BI is also a root. That means you get Z minus of A plus BI multiplied by Z minus A minus BI. You will always be able to simplify it as Z minus A minus BI and Z minus A plus BI. Do you see the pattern?
Yeah.
X minus Y times X plus Y. So it's X squared minus Y squared. Always will have this pattern. So yeah, you can use this trick. So, but anyways, it's just expansion. Eventually, you'll simplify it down into X squared minus 2X plus 2. Is that okay?
Okay.
Alternative is just multiply, multiply everything one by one. But you realize it's like 3 terms and 3 terms, so you'll get a total of 9 terms, which is a bit slower. So using this trick, this is just a shortcut, helps you to save time. If you don't understand this, never mind, just do it. Just do it. Very fast one. Oh, you get x squared minus 2x plus 2. Then this one, 2x squared plus 8ax plus b, just copy down. You can't do anything yet. For now, until the next step, now you can start to compare coefficients. So they start by comparing constants. Constant here is -2. Constant here is b times +2. So it's 2b equals -2. Solving for b, you get -1 divided by our 2. Is this b okay?
Yeah.
Then now you compare coefficient of x cubed. How do you get x cubed? Maybe I'll highlight it in green color. X squared times x. That gives me an x cubed. X times x squared. That also gives me an x cubed. So it's ax cubed and minus 4x cubed, which is a minus 4 over here. And then you got a -4, so coefficient of x cubed here. So -4. I think the mistake that you made here is you wrote down a 3. Let me show you. Is it this one? Oh, it's not this question yet. There was another time you compared the wrong coefficient. Okay, it's not this one. Yeah, so anyways, you can solve for a now. A equals to 0. So if a is equal to 0 here, you just have, this will just disappear. Then you're left with 2x squared plus a b, which is plus a -1. So 2x squared minus 1. Okay? Then after that, you can square root as, rewrite it as square root 2 squared times x squared, which is square root 2x plus 1 and square root 2x minus 1. Maybe if I just show you some working, 2x squared minus 1 is the same as square root 2x bracket square minus 1 square. A squared minus b squared, then you can get a plus b times a minus b. Is that okay?
Yeah.
Okay, good. Question 10 done. Next. Question 11. Okay, you could do it, most of them, part A and part B, at least. But you didn't do the exponential form. The question asked for exponential form.
Oh.
Just one step only. This is your r, that's your cosine theta plus I sine theta. Then that's your r, e, I theta. Okay? Easy, right? Just memorize only the formula. R, e, I theta. R, e, I theta. Okay? Next one. Same thing. You got the correct angle, you got the correct radius length. So you just convert into exponential form. R, e, I theta. Okay? Now for part C, this one is a problem. Here, maybe I didn't explain clearly enough. Whenever you have the extreme cases where it's where you have a complex number that lies along these two axes, you should just be able to identify the angle straight away. Look at your diagram here, -6. This is the complex number. It's like a vector starting from the origin. What's the angle? Is it anti-clockwise or is it clockwise? You can tell the answer from the tick and the cross. Should be anti-clockwise. Why? Because we want to have a principal argument that goes from -pi to +pi, inclusive of +pi. Okay? Include +pi. That's in the syllables, by the way. It's written in the syllabus.
Argument.
Principal argument. Yes. The argument. The theta is the argument, right? The arc z. Arc z argument. So it must be the positive angle. And it's just 180 degrees. So pi. You don't need to do any tangent inverse or anything. Okay? So here, wrong. No. Don't need to tangent inverse. You should conclude straight away the angle is pi. Then the r is very simple. The length here. What's the length here? 6. I got 6. Don't need to use the square root, whatever. No. Don't need. Nobody will ask you to ask for this working. We can see straight away it's 6. Just conclude it's 6. Okay? Is that clear?
Yeah.
By the way, should it be +6 or -6?
Positive.
Must be positive. Why? Because r is length.
Length.
Like distance formula, right? Vectors. Length cannot be negative. So it's always positive. So what's the correct way to present this? Instead of 0, wrong, it should be a pi. This is wrong. It should be z3 equals to 6 multiplied by cosine of pi plus I sine of pi, which means that the REI theta format will be what? Can you try?
6 EI pi.
Yes, exactly. That's all. Okay. You can verify what's cosine of pi.
-1.
It's -1. Then wait, let me just resize this. I'll send you the updated file later. I need more space for this. Yes, correct. It is -1. This guy is -1. Then how about sine of pi? It's just a 0. So you get -1 plus I times 0, which is -6, because you have a 6 in front. Makes sense, right?
Yeah.
6 times -1 plus 0, which is still -6. So this definitely still works. Okay. Trigo form. Can moving on. Now for part D. Part D, how? You got I. Can you try it now? Where's I? Over here, right?
Yeah.
Where's I? One I. Then there's a vector like this. So can you conclude straight away what's my R, what's my theta? R should be
1.
length. Yes, good. Don't need to square root.
The theta is 0.
Wrong. You must always, how do you measure angle? Like let's say you have a vector like this. It's this way, right? Anti-clockwise. What if you have a vector like this? Start from the positive x-axis, turn anti-clockwise, and you reach the angle. Then if I turn a bit more until here, you still turn from the horizontal.
Oh, so it's 90.
Yes, exactly. But you must use radians.
Pi.
Pi?
Pi over 2.
Over 2, yes. So pi over 2 is your answer. Correct. So therefore, conclusion. Z4 is equals to
EI pi over 2.
No, you didn't write the trigo form yet.
Oh,
You didn't even have a trigo form yet. You said undefined. Wrong. No. Yes, it's undefined because you're taking tangent inverse, but you're not supposed to take tangent inverse. Okay? It's undefined at pi by 2 because if you remember the infinity at pi by 2, right?
Yeah.
Tangent inverse, then you will get infinity. You get a reverse answer. So this is r times cosine of theta pi by 2 plus I sine pi by 2. Then of course, if you convert it into REI theta, yes, 1 EI pi by 2. Of course, if you times 1, you don't need to write the 1. Okay? And just drop the 1. Okay, Ken?
Cannot
Let's try.
convert straight from the.
Can. No, I'm just answering the question. You can convert straight, yes. Because the question asks for trigo form and exponential form.
Oh,
That's why
right.
I'm just
Okay.
answering the question. Yeah, you can skip it straight away, of course. Can. I'm just answering the question. Okay.
Okay.
Okay, next question, question 12. Okay, this one quite complicated. What do you do wrongly? Let's see. Okay, nothing wrong so far. No. Over here is correct. Up to here, your Z. You just need to realize it. Okay, let me show you how you can do it. This is different from the answer key, but I'm just following your thought process. Here, how we can continue it is let's read the question first. Let's jog our memory. What were they asking for? They started off by giving us a Z equals whatever. They want us to find modulus, find argument of complex number Z. This fella here. In other words, find mod Z, find arg Z. So I hope you remember the properties of argument and modulus.
Yeah.
This kind is like logarithms plus. Very good. Okay, just please go and recap on that. I already going through this. I don't want to go through again. Just recap the formula. I'll use it as I need it. So here you could have done that. You could have just started off by mod Z equals to modulus of the 1 minus I square, and then modulus of the 1 minus square root 3i and power 4. You can take out the power if you remember one of the rules. Modulus of Z power n is modulus Z, then factor out that power n.
Yeah.
Yes? Okay, good. So you could do that, but sorry. I'm sorry. Yeah, you can do that, but let me show you a different way that is different from the solution using your thought process. You started off with substituting the everything with x plus iy, I think. Is that what you did? What exactly did you do? Oh, you simplified everything into a negative I over negative 4 plus 4 root 3i. That works. How you simplify the z. Then how do you continue? Let me show you how I can continue your working. This is an alternative method that's not in the solution. So what I started off with is to how I started it is I factored out a negative 4 from the denominator. So I'll get a negative 4 bracket 1 minus root 3i. Then that's only to make my life easy so that my numbers here are smaller. Then now I try to realize the denominator, multiply by the conjugate top and bottom. 1 plus root 3i. Minus become plus. Then simplify, I'll get 1 square minus root 3i bracket square. This becomes a 4. Okay. Then the numerator, I multiplied by 1 plus root 3i. I multiplied by 1 plus root 3i. Distribute the I get I plus root 3i square. Also, by the way, there's a negative at the top and bottom, so I just cancel them off. Sorry, I forgot to mention that. I cancel them off already, that's why I'm left with I and a 1 plus root 3i. Then I multiply them together to get I plus root 3i square. Is that okay? Mike, can you hear?
Why the negative 4 become plus 4 though?
Over here. Negative. Cancel off, become positive. So essentially it disappears. You're left with an I and a 4. Can? Then I multiply by conjugate top and bottom. Simplify the denominator to a 4. But don't forget there's still a 4 here outside the bracket. Right? Outside the bracket. Only the minus disappear, the 4 still remains. Then there's an I outside of the bracket, you times in. You get I times 1, which is I times root 3i, which is root 3i square. I square is negative 1. So you get minus root 3 plus I, which is what I have over here. Then the denominator 4 times 4, 16. Clear so far?
Yeah, can.
I split out into a plus bi, negative root 3 over 16 plus 1 over 16i. Can? Then now you want to find modulus z and argument z. How? Modulus of z is just square root of a square plus b square. So you can calculate it over here. You eventually simplify it down to 1 over 8. Then we get our answer. Another way argument z. First, you must look at this, then draw on your Argand diagram where is negative and positive. It's over here. So your alpha is over here, which means you need to take pi and you minus away alpha. Oh, so I write down pi minus alpha. Then it's really just pi minus tangent inverse of, you take the positive version of b over a. That's my b, that's my a. Ignore the minus. Okay, can now? Simplify, you get tangent inverse of 1 over square root 3 over here, which is just pi by 6, 30 degrees. Exact values. Then subtract, you get 5 pi by 6. Then that's your answer for the first part. Okay, for the first part. Let's read the question. Find modulus and argument of this fellow. We found it already. Hence, evaluate z power 6. So really, the simplest way is to find out your r, find out your theta, then rewrite it as REI theta. Okay, find r, find theta, then use the formula. So how to find the r of z power 6? How to find the theta of z power 6? This is when it will be super useful to use the properties, right? The modulus and argument properties. Let's see how I did it. So I start off with, oh wait, actually no, I did it a different way. Oh right, this is actually slightly easier. Sorry. How I did it was I start off with concluding that r equals 1 over 8 and theta equals 5 pi by 6 in z. So I can conclude the exponential form is REI theta 1 over 8e I times 5 pi by 6. Is this okay? Then now I want to find explicitly z power 6. So I can just raise both sides to the power of 6. Raise both sides to the power of 6. That means I'll get a times b power 6, which is what I have over here in red color. Is this part clear to you?
Yeah.
Oh, the rule is like this. A times b power 6 is a power 6 times b power 6.
Yeah.
Okay. Then 1 over 8 power 6, you can use calculator. 1 over 2, 6, 2, 1, 4, 4. Then this guy power 6, you just have to multiply the angles, multiply the powers. So 5 pi over 6 times 6, 6 cancel off, you're left with 5 pi. So far, okay? Good. Then this one, you can rewrite it as cos theta plus I sine theta. So you get cosine 5 pi plus I sine 5 pi. What's cosine of 5 pi?
-1.
It's -1. How do you calculate that? You have to remember the cosine graph. This is 2 pi. There is 4 pi. Then if you add on one more pi, where would it be? 90, 90, 180. Pi is 180. So you end up here. What's the y value of that point?
-1.
-1, exactly. So that's why you get -1. How about sine 5 pi is 0? How do you get that? That's 2 pi. This is 4 pi now. Then you want one more pi, so half of it. So somewhere here.
But can key in the calculator?
Yes, I actually also can. That's a faster way. I like to do it manually. Sorry. Okay, yeah, use a calculator. Use a calculator. That's faster. Yes, 0 and -1 and 0. So 0 times I, then you just straight away cancel off. You're left with -1 times whatever number. Then you just get this as your answer. Okay.
Okay.
There is another solution which they did by converting each of the complex numbers into REI theta format straight away. So 1 minus I, you can find the R is square root 2. Then the angle as well, you can find out it's -pi by 4. Do you need me to show you?
Yeah.
Okay, can. 1 minus I, let's see where is it. Over here. 1, -5. This is imaginary. That is real. Let me just move things over so I have more space. Wow, I draw so small. Very bad drawing. Let me try again. Sorry.
Okay.
Imaginary, real, somewhere here. That's 1, that's -5, that's the theta. Always start from positive real axis and then you turn either clockwise or anti-clockwise. Whichever is smaller. Which is smaller? Starting from here. Anti-clockwise or clockwise?
Clockwise.
Clockwise is smaller, so that's why this is our theta. So let's figure out what is my R. R is just square root 1 square plus -1 square. Right, 1 minus I. Oh, sorry. Okay, 1 minus I. Okay, then in that case, you can just get the square root of 2. How about the theta? Theta in this case is negative of tangent inverse, correct?
Mm.
This is like alpha, but you have a negative because of the direction clockwise. So it's just tangent inverse of 1 over 1, right? The b over a. The b in this case is -1, but I just throw away the minus. So I get +1. Then divide by 1 here. Oh, I think I saw what you did. You put modulus, right?
Yeah.
Yeah, that also works. So you get b over a -1 over 1. That also works. Okay, so tangent inverse of 1 is just pi by 4. So negative pi by 4. Okay,
Can.
good.
So I
Then,
put the modulus will always be correct.
yes, to get the that's why I want you to do. Make it positive.
Okay.
Positive b and positive a. Then after that, you modify accordingly to which quadrant it is in. Then likewise for 1 minus square root 3, it's just the same thing. It's just I change from a -1 to a minus square root 3. So I'm not gonna go through this.
Mm.
You can work out the same angle. Then why did they do that? Because now when you got a square, you got power 4. Whenever you got exponents, it's smart to convert it into exponential form, hence the name. Because now you got a square, what do? You can just times into each of them. So you get root 2 square, which is a 2, and then e to the power of whatever squared. So you just multiply the angle by 2. Pi by 4 times 2, negative pi by 2. I. Bring along the I. Likewise for your power 4 here, you just bring in. So you get 2 power 4, which is 16. And then e power negative pi by 3i multiplied by 4. You get negative 4 pi over 3i. Is that clear?
Yeah.
Okay, good. So simplifying, you eventually get 1 over 8. 2 over 16 is 1 over 8. Then e power something. Same base, different power, you divide, what happens? You have to subtract the power, right?
Yeah.
Okay, if I write it out manually, subtract negative 4 pi over 3i. Oh, simplifying the angle, you will eventually get to 5 pi over 6i. Can?
Yeah.
Okay, good. Yeah. So because of exponents, you have to bring up, then you have a minus. Can you see now that this is really just the argument of 1 minus I power 4 minus away argument of 1 minus square root 3i power 4.
Yes.
Yes, right? This fella here, the numerator is 1 minus I square. Oh, sorry, square, not power 4. Numerator 1 minus I square. Then argument means you're looking at the angle of that complex number, which in this case is negative pi by 2. Oh, negative pi by 2. If you just drop the I, And then the 1 minus square root 3i power 4, argument is negative 4 pi over 3 over here. And then you subtract. That's why when you start off with a fraction, you take the argument of a fraction. Like in this case, the fraction is 1 minus I square over 1 minus square root 3i power 4. It's just the argument of the difference. You can see it from this example. Right?
Yeah. Okay.
So that's actually a proof. That's a proof of why this formula works. Argument of a quotient is the difference of the arguments. Sorry, give me 20 seconds. Okay, back. Sorry.
Okay.
Yeah, so okay, you get up to this step. Maybe I should change to a different color. This is extra working. Change to a blue color. Here. Okay, then this is your 2 over 16 times e power whatever, simplified into this. So you can conclude straight away that your z power 6, you just have to take this to the power of 6. Power 6. Then times 6. Then you eventually get to this, which you simplify into this. 1 over 8 power 6 is just 1 over 262,144. Then e power I 5 pi. Oh, by the way, do you know that cosine of let's say you got some angle alpha, and then you add on alpha plus 2 pi, it's the same.
Yeah,
Yes,
because
right?
of the graph.
Yes, every 2 pi it will repeat. Oh, this is what we call a periodic function. Periodic function. Whenever you add on a certain amount, it just repeats itself and it stays equal. Likewise, if you add on another multiple of 2 pi, so now it becomes 4 pi, add on another multiple of 2 pi, you get to 6 pi. Or even if you subtract, let's say cosine alpha minus 2 pi or minus 4 pi, it will always be equal. Does it make sense?
Yeah, makes sense.
So this also applies to sine. So that's why over here, the 5 pi, you can reduce it down into pi. It's because what you did is you converted it first, ei 5 pi, you convert it into cosine of 5 pi plus I sine 5 pi. But then you take away 2 pi 2 times, minus 2 pi, minus 2 pi. Then you'll end up with a pi. It will still be equal, right?
Yeah.
We just concluded. So that means that cosine of 5 pi can now become cosine of pi. Sine of 5 pi can now become sine of pi. This is exactly equal to cosine of pi plus I sine of pi. Since the angles are the same, there's a plus sign in between and there's an I over there. This is really just equals to E I pi by definition. Can?
Can.
Okay, good. Then in that case, E I pi is what? It's a famous identity. Remember the most beautiful equation?
Oh, yeah.
Yeah. Of course, it's just evaluating this. This is -1, this is 0. Oh, nothing special. So this is equal to -1. That's how you get a negative here. Okay. Yeah, okay, good. That is the alternative. Then yet another alternative is to straight away use the modulus and argument properties. So modulus z is just modulus numerator square and modulus denominator power 4. Then you get root 2 square, 2 power 4. You know how to find the modulus. I think I don't need to explain this, right?
Yeah.
Square root a square plus b square. Then power 4, power 2. Then you simplify, use a calculator, 1/8. Then here, argument of z is argument of the fraction, which you can split up as argument of numerator. Maybe I write in one more line now. Argument of, I wrote it down on top already actually. Minus away argument of 1 minus square root 3i power 4. Then in that case, you got a power. What do you do with a power? You have to
Take out, like put in front.
Yes. Bring it in front. Bring it in front. Okay. So you get 2 times of argument 1 minus I. Take note, this is not differentiation. You don't go and bring down the old power -1 to get the new. You don't go and bring down a 4 and change this into a -1 and get a 3. Please do not do that.
Okay.
Bring it entirely in front, okay?
Yeah.
Can? Don't confuse with differentiation, okay?
Okay.
Just bring down. Okay, then you get 2 times of argument, 4 times of argument with a minus in between. All right, then how to find argument? I explained just now already. I'll just draw the diagram. Okay, I explained the -5/4. I didn't explain -5/3. I think you understand. Right? Do you need me to explain this?
Don't
need? Okay, good. So simplify, you get 5/6. Good. That's not enough, because that's just z. Now we actually need z power 6. So we can take modulus of z power 6. It's just modulus of z, then you take power of 6. So it's just 1/8, then you take to the power of 6. You again get your 1/262 1/4. How about argument of z power 6? The 6 there, you can just bring down. Get 6 times of argument of z. 6 times of argument of z means 6 times of 5 pi by 6. What happens to your 6? Cancel off. You're left with 5 pi. Then you can conclude, that's my r, that's my theta. R times cosine theta plus I sine theta. Okay? Using the formula. Then again, same thing lah. Cosine 5 pi is -1, sine of 5 pi is 0. Then you simplify to this. Okay, 3 different methods. You can pick whichever one you want. Okay? Can. Let's move on. Question 13. Okay, question 13 we went through already. Let's see what went wrong with your method. Oh, okay. Binomial expansion you never expand properly. You never use the formula. You try to do it manually, but you end up making a careless mistake here. C square.
Oh.
You didn't put a square, then everything wrong already.
Oh, okay.
Right? So just use the formula. Just
Okay.
use the formula. You must recognize when you can use formula. Don't do it step by step. Very slow. And you see so many tiny little terms going around. You don't have time to write it all. Use binomial expansion. You only got what? 4 terms to work with. Oh,
Okay.
can use binomial expansion. I'm not gonna go through. I went through already. You can go and watch the video again. Part 3 circle. Yeah, I went through already. Go and watch the video. Then I got an explanation already. Just use a GC. I also demonstrated how to use the GC. I don't want to talk about it again. Don't waste your time. You can watch the video again. Okay, question 14. Let's go on. 14. You never answer the question. You simplified. You got your WZ, and also again, bad habit here. You write down W times Z, but you never write down WZ at the side. Okay, WZ equals. Okay. Then after that, you need to find the modulus and the argument. So you just need to answer the question. 2 root 2 and negative 13 pi over 12. Answer the question. You never answer the question. Okay?
Okay.
Yeah. How much time do I have? Do you need to rush off?
Don't need.
Okay. Can we have a short 5-minute break first?
Sure, sure.
I need to use the toilet. I'm so sorry.
Okay.
Okay.
Can.
We will come back. 5 minutes.
Mm.
Maybe less than that. I'll see how. Yeah, you use the toilet or something.
Okay.
Mic test.
Yeah, can hear.
Oh, you're here already. Okay, Ken, let's just go through question 14 now. Can hear, huh?
Can.
Good. Can you see my shared screen?
Yes, can also.
Okay, good. Ken, let's begin. So question 14, you already, actually, let me just see. You almost got it. You got the angle here, but oh, there was a slight mistake. Negative 13 pi over 12. If you convert it into degrees, what is it? Times 180 over pi.
Negative 195.
Yes, huh?
Yeah.
Did you get it? How I got it? Yeah. Just times 180. Sorry, times 180 divided by pi. The pi cancel off.
Yeah.
And good. So negative 195. What is the principal angle again? It's negative pi less than, strictly less than theta less than or equal to pi. Theta is the same as argument of a complex number z. This is 180 degrees positive. This is negative 180 degrees. Is this inside the interval?
No.
No, then what do you need to do?
Need to like plus.
Yes, you need to plus. Plus means you go clockwise by adding on 360 degrees. But we don't work with degrees in A levels, we work with radians. So it's not negative 195 plus 360, it would be plus 360 in radians.
2 pi.
Exactly, it's 2 pi. These are equal. Yeah, so you add on 2 pi. Then you will get your 11 over 12 pi. Can?
Can.
Sorry, I forgot to mention that. Yes, quite important. Must always keep within the interval. The negative pi to positive pi. Must always keep within this interval. Okay, so now in that case, we can answer the question properly. 2 root 2 and 11 over 12 pi. Let me just go back and mark your question again. This is wrong. Sorry. This one not correct. Still need to convert into the principal range. So it's 11 pi over 12. Yeah, okay, can yeah, this is wrong. Sorry. This is wrong. No. I'll send you the updated file later. Okay. Ken, that's question 14. The first part, modulus and argument. Then how do you continue? They also told you to rewrite the w and z in the form of x plus yi. What does that mean? You got w, you got z. Rewrite as x plus y. How do you do it? Do you want to try? Okay, take a piece of paper and pen and write it down. Exercise. Or you tell me verbally, maybe it's faster. W, how do we convert into?
Is it square root 2 plus I?
Wait, let me copy this down first. Sorry, you were saying?
Square root 2 plus I negative 3 pi over 4.
No, 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 no. No, 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 no. How is that related to the E? Something plus I times something. How is E power something related to something plus I times something? Doesn't it sound familiar? Something plus I times something.
Oh, I must convert to the trigo first.
Yes, correct. That's the
Oh,
only way that I know of. That's the easiest way to convert into x plus yi. And I believe it might be the only way. Don't quote me on that. But it's one way you can do it. So that's what we're going to do. Okay, review the answer. So what we're gonna do is to first find out W. What is the modulus and argument first? I think it's obvious. It's actually given already. Modulus is root 2, argument is negative 3 pi by 4. Okay, let me just copy down the question so it's easier for me. Just paste it here temporarily. Yeah. So you already know modulus is root 2, argument is negative 3 pi by 4. Likewise for the other guy, modulus is 2 and negative pi by 3. Huh? So that means that we can immediately find out what is our W and our Z. Right? We can find out our W and Z. Just convert into trigo form. R bracket cosine theta plus I sine theta. But cosine theta, we can calculate that, right? It's just, let me just double check with my calculator. Do I get the exact answer? Cosine of negative 3 pi by 4. I can't get an exact answer. So how do I calculate this if I want the exact answer, negative 1 over square root 2? How? I'm asking a question.
Oh,
Fill in the blank. How? You need to understand your ASTC. Do you remember ASTC? Again, it's secondary school AMAX. And you need to understand basic angle or alpha. So what you need to do first is, where is your negative 3 pi by 4? Draw a picture. So negative 3 pi by 4, if you don't want to use the negative angle identity, of course, you can, but let me just show you an alternative way. 3 pi by 4, if you cannot remember, then where is it? Then just convert into degrees times 180 over pi. So what do you get?
So I find the basic angle.
In degrees first. Yeah, correct. But find out. Let's just figure out what's the degree first. Yeah, I think it's 135. Is it?
Yes.
3 pi by 4 times 180 over pi. Pi cancel off. So you're left with 3/4 times 180.
Okay.
Pi there, cancel off. Oh, but that's negative 135. So where is it in the quadrant? Negative clockwise or anti-clockwise?
Clockwise.
Clockwise. So it's here 0, here negative 90, here negative 180. So 135 is somewhere in between here. Then where's your basic angle? It's over here. What's the angle? Pi by 4 lah. Right? It's always positive, basic angle, your alpha. Handwriting. Let me try and use a smaller font size. Pi by 4. Yeah, close enough. So that means that you get a pi by 4. So this is really just cosine of pi by 4. Correct or not?
Oh.
Then what's the sign? What quadrant are we at? T. We're in T. So plus or minus?
Minus.
Okay. Then you can simplify. Actually, is this correct? Let me think a little bit. Yeah, correct. Okay, then cosine pi by 4. I hope you remember. It's just 1 over square root 2 lah. Then that's how you get negative 1 over square root 2. This part, if you cannot calculate it, cannot remember, then you must use the trick. Did I explain this trick to you already? Square both sides. So cosine square of pi by 4 will be equal to 1 over 2. Is this correct? Can you type this in the calculator? Do you get a 1 over 2?
Yes.
Then how do you get the exact value of cosine pi by 4 from cosine square? How do you go from square to no square? Take the
square root.
So take the square root manually and you will get square root 1 over 2. Simplify square root 1 over square root 2. What is square root 1? It's just a 1. Square root 2 remains. There you go. You managed to use the calculator to help you to remember 1 over square root 2. Do you understand?
Oh. Yeah.
It's a hack. It's a hack. So you need to remember cosine, sine, and tangent always got a square root 1. In fact, you should already remember, you should know this table already. 30 degrees, 45 degrees. 60 degrees, aka pi by 6 radians, pi by 4 radians, pi by 3 radians. You got sine, this is theta, cosine, you got tangent. The values are, I show you the pattern now. Over 2, over 2, over 2, over 2, over 2, over 2. Square root, square root, square root, square root, square root, square root, square root. Sine, if you think about it, 30 to 45, 30, 45, and 60 degrees. Look at the graph. This is sine, okay? Sine.
Yeah.
Here's 30, here's 90. So 30 to 6, 30, 40, 30, 45, and 60. 30, 45, and 60 is all in between, right? All in between here.
Yeah.
What do you notice about the graph? Is it increasing or decreasing?
Increasing.
Increasing. So you expect increasing number. So in nursery and kindergarten, what is the first few numbers you learn?
1, 2, 3.
1, 2, 3. So you put down 1, 2, 3 here. That's the values of sine for 30, 45, and 60. Can you remember?
Can.
Verify with a calculator if you don't believe me. Oh, check. Square root 2 over 2. Square root 2 divided by 2, type in calculator, 0.707. Then now you try typing sine 45 degrees. Or sine pi by 4.
Yeah.
Same, or?
Same.
Then let's try the other. Okay, then you can verify this on your own as well. Sine of 60 degrees or sine pi by 3, you get 3 over 2. How about this one? Cosine. Can you remember how the cosine graph looks?
Yes.
So over here, 30, 45, 60. Maybe I need to use a thinner pen. Like this, 30, 45 degrees, 60 degrees. What do you notice about the graph? It is
Decreasing.
decreasing. So you want decreasing. What would you expect the values to be?
3 to 1.
3 to 1. Check, is it the same or not? Square root 1 is just 1, so 1/2. Oh.
Yes.
Can and do you notice a pattern? Same.
Oh.
Why? Is it a coincidence? It's not a coincidence. The reason is the co-identities. I call it the co-identities. How? Sine of alpha equals to cosine of beta. Likewise, secant of alpha is equals to cosecant of beta. Likewise, tangent of alpha equals to cotangent of alpha. Beta, where alpha plus beta adds up to 180 degrees. Sorry, no. Complementary identities. 90 degrees. Apologies. 90 degrees, not 180. Okay? This is always true. Have I shown you this? Did I show you this?
No.
Okay, let's say this is alpha. You got a right angle triangle. So what's the angle at the top?
90 degrees minus alpha.
Which is, if you follow this formula, what's 90 minus alpha?
Beta.
It's just beta. Okay, very good. So that means we can now, let's just label A, B, C. So let's verify that sine alpha, we're going to prove. Sine alpha equals to cosine beta. So sine of alpha is what? Tuakaso. Which one? So sine is?
So.
Then what's a fraction?
B over C.
Very good. Now let's take a look at cosine of beta. What is it?
It's A over C.
What? Angle B beta is here, adjacent over hypotenuse.
Oh, B over C.
B. Yes, B over C. Okay. A over C. Okay, B over C. So they are the same. Oh, it's always the same. They are both B over C. So sine alpha equals to cosine beta. Okay, this applies to all triangles as long as they add up to 90 degrees. You can check also secant alpha, cosecant beta, tangent alpha, cotangent beta. The trick here is no co, yes co, no co, yes co, no co, yes co, co no co, co no co. I call them the co-identities. Do you want me to verify for you this other two?
Don't.
Don't need, usually you only need to use the first one. Oh. So over here, how does it apply in this case? 30 plus 60, 90. 45 plus 45, also 90. So that's why cosine of 30 and sine of 30 degrees and cosine of 60 degrees. 30 plus 60 is 90, right? That's your alpha, that's your beta. So sine alpha, cosine beta, they are the same. Here you also got alpha and beta pair, 30 and 60. Here you got another pair, 45 plus 45. Okay, that's why they are the same. It's not a coincidence. This two same, this two same, this two same. Not a coincidence. It's the co-identities. Oh, the first one. The first of the co-identities. I already proved it over here. Right? Always true. The A, B, and C can be any values, any length, provided you have a right angle triangle. Okay, then tangent. Tangent, you must remember, is sine over cosine. So this over this. Isn't that just 1 over square root 3? The two cancel off. This one is just 1. Because sine over cosine. Same value, cancel off. So you get 1. Then this over this, root 3 over 1. Right, you just flip it around. Flip. Right, because 1 and 3, 3 then 1. That's why it's flipped around. Flip. Flip. Okay. This is the table. Look familiar or not? This is from Amex, huh?
Yeah, familiar, but I never memorized.
You never memorize.
Yeah.
How did you do your questions? Okay, please, you need to know this. Alternative is to do this trick. Square already, then you manually square root. Okay.
Oh, last time I just remember the decimal is equal to what fraction.
Oh, wow, that's even worse. Okay, okay. How you should actually understand this is to remember the triangles. There's 2 triangles you should know. Sorry, I should mention this at the start. This is a 60-degree equilateral triangle. So that means this here is a 60 degrees, right? 60 plus 60 plus 60 gives you 180. Then you split it in half, a perpendicular bisector. So here is perpendicular. Bisect means what? Means this part here split into 2 equal halves. So if I force this length to be a 2, 2, and 2, I can now split it up as 1, 1, right? Because it bisects. Perpendicular bisector. Then what's the remaining length here? Square root 3 lah, Pythagoras theorem. Then here, if it's 90, that's a 60. What's the remaining angle? It's a 30 degrees. So what does it mean about sine 60, sine 30, cosine 60, cosine 30? You get these values. But take note that you will get the irrational version. You'll get like 1 over square root 2. This is square root 2 over 2 is the same as 1 over square root 2. You know this, right?
Yeah.
Okay, then I don't write it. It's very messy. Okay, I'll just leave it. It looks nice like this. Easier to remember also. 1, 2, 3, 3, 2, 1. Yeah. So likewise, there's also a second triangle. This is called the isosceles triangle. Isosceles meaning the 2 sides are equal, and isosceles right angled triangle. So what's the angle over here? 30, 60.
45, 45.
45 degrees, and because isosceles base angles are equal, of course, it's another 45. Let's force this length here. Oh, sorry. Let's force these 2 lengths here to be 1, 1. Then what's the remaining length?
2, square root 2.
2. So that means you can find your sine 45, cosine 45, and tangent 45 as well. Oh, okay. From these 2 triangles.
10.
Okay, this is equilateral split half. Perpendicular bisector. Then the other guy is a isosceles. Equal length here. Yeah. Okay, that's how you derive the table of values. Anyways, moving on. I assume you know this, Then so cosine pi by 4 is just 1 over square root 2 or square root 2 over 2 with an extra minus sign. What's an alternative way to evaluate this exact value? It would be to use the identity. If you remember, cosine negative theta equals to cosine theta. So cosine of negative 3 pi by 4 is nothing but just cosine of 3 pi by 4. Sorry, your 3 should be on the numerator. Like this. Can?
Can.
Then what's cosine 3 pi by 4? Then you do the same procedure. Where's 3 pi by 4? It's somewhere here. Positive 3 pi by 4. So where's my alpha? It's somewhere over here. So alpha is really just pi by 4. You take 180 minus 3 pi by 4 or pi minus 3 pi by 4. Okay, then after that, you will get pi by 4 here, but with a cosine. And then, sorry, I need to change the font size a little bit. Cosine, then what's a sign here? A, S, T, C. Quadrant 2 is S. So what do you need over here? Plus or minus?
Minus.
Minus, because cosine, only sine is positive, everything else, cosine included, is negative. Also negative cosine pi by 4. Negative cosine pi by 4, again, is negative 1 over square root 2. That's another way to evaluate it. Can, Okay,
Can.
good. So that's how you evaluate. That's how you go from here to the exact value, negative 1 over square root 2. How about sine? Okay, now you try sine negative 3 pi by 4. Let's try the formula way. Give you a hint. Sine negative theta is negative sine theta. So this is equal to?
Negative sine 3 pi over 4.
Very good. How do you calculate that? Draw what?
Draw the
X and Y.
diagram.
Okay. Then where's 3 pi by 4? Here, 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 here. Option 1, 2, 3, 4. Where is it?
4.
Correct. Yes. Okay. Okay, so it's over there. Then is it anti-clockwise or clockwise? Clockwise or anti-clockwise? As your theta, 3 pi by 4. Which one?
Is anti-clockwise.
Anti-clockwise is the smaller one, 3 pi by 4. Then where's your alpha? Is it here, alpha? Or is it there? Here or there?
The small one.
Both look very small. Sorry, not clear enough. Let me try again. This is number 1. This is number 2. Which one?
Number 2.
Number 2, exactly. That's your alpha. Sorry. Okay, good. Then that is number 2. That's your alpha. Then how do you find alpha? 180 degrees.
So it's
180.
pi minus 3 pi over 4.
You can do that in your head or in your calculator, and the exact value will be pi by 4. Agree?
Yeah.
1 whole of pi means 4 quarters of pi. 4 quarters minus 3 quarters, left with 1 quarter of pi. Can? Pi by 4. Can?
Can.
Okay, good. That's pi by 4 then. So this is equal to what?
So it's negative sine pi over 4.
Negative. Why negative? Okay, let's think ASTC. Okay, it's correct. It's correct. But don't need an extra negative?
Don't need.
What's the logic here? Sine 3 pi by 4. Yes, you're saying.
Because it's in the sign, so like if the sign is positive.
Correct. Yes, exactly. Correct. Yes. So you just need to sine 3 pi by 4, replace with sine of the acute angle alpha, and then you decide, do you need a plus minus here? Quadrant 2? Don't need. Do you need minus here? You don't need. You just need a plus sign. So, but then don't forget the minus that you brought down from before. I just copy and paste it so you can know it's exactly the same. These two are the same. I just copy and paste. The negative here is not because it's in quadrant 2, it's because I bring down from above. Okay. Then sine pi by 4 is 1 over square root 2. So that's your answer. Square root 2 over 2 equivalent. Okay, what's another way? Sine negative 3 pi by 4. This one I show you. Negative 3 pi by 4, you can draw a diagram. It's negative of 3 pi by 4, so it's somewhere over here, and it's clockwise. Negative 3 pi by 4. Then the alpha is over there. Again, it will still be pi by 4 straight away. But ASTC, This is t. So what's a sign here? I mean, SIGN sign. Convert into sign of the alpha, but then plus or minus.
Is minus.
Minus, yes, correct. Because tangent t here means that only tangent of any angles in this quadrant will be positive. Every other angle you take every other ratio, sorry, sine or cosine, you try to take that ratio of this angle in this quadrant, you will just get a negative. Okay.
Yeah.
Tangent positive, sine cosine is negative. So that's why here is sine, here is a sine, so that's why it's a negative. Then what's pi by 4? 1 over square root 2. Sine pi by 4, it's 1 over square root 2. Okay. Then you'll get negative 1 over square root 2. Is that clear?
Yeah.
Can okay, finally, we get our negative 1 over square root 2. This one you have to work, practice and practice and practice until you can do this under 10 seconds. Or 5 seconds. Yeah.
Okay.
Try it. Legit. I'm not kidding. I'm not kidding. This one you cannot afford to waste much time doing. Need to do a lot faster. Okay. This cosine is negative 1 over square root 2. Sine is negative 1 over square root 2. Okay. Then we can finally times in the square root 2, get negative 1. Times in the square root 2, you get negative 1. Okay.
Yeah, can.
W done already. Z. Same thing again. Remember, maybe read the question again. What were we doing? We got W, you have modulus argument. You got Z, you got modulus and argument. Find modulus and argument of WZ. Found that already. Then now we want to express W, express Z in the form of X plus YI. How did we do that? We first express it as an exponential form because we got R, we got theta. Then what we are doing now is we convert into trigo form. Cosine theta plus I sine theta. Then we have to calculate the exact value, all that nonsense we were talking about. 1 over square root 2, negative 1 over square root 2. Then after that, you multiply the square root 2 inside, don't forget. Then you eventually get to your X plus IY, X plus YI. Same thing. Which is over here. Right? Minus 1 minus I.
Yeah.
Good. We have finally finished our Cartesian form for W. Now we move on to do the same thing for Z. Express Z in the form of X plus YI. Now we are done with W. Now it's time for Z. It's Z's turn. So Z, what do you do? Exact same thing. You got the modulus and argument they gave, the question gave us. So R bracket times cosine theta plus I sine theta. Yeah. Then cosine negative pi by 3, you get 1/2. Do you know how to get that?
Yeah.
Let's just do a quick one. So negative pi by 3 is actually negative 60 degrees. So it's actually, if I use an identity, this would just be cosine of pi by 3. Cosine 60 degrees, right? Because of the identity. Then this is just exact value, 1 over 2. Okay? Square root 1 over 2, which is just 1 over 2.
But I cannot just key in.
Let's see. Actually, if you key in, you can, it will work for half lah. It will work for half. But if you square root 3 over 2, can you get the exact value? Depends on your calculator model. Some calculator can, but mine cannot. It will give me decimals. Also, the sign may not be reliable. The negative sign may not be reliable. The calculator uses an approximation to get sine and cosine. It's only reliable for angles that are positive. When it's a negative, use at your own peril, at your own risk.
Oh, okay.
So here I would recommend using the identities lah.
Okay.
So sine of negative pi by 3 is really just negative times of sine pi by 3. Only sine and tangent can take out the negative. For cosine, you cannot. Must remember, sine and cosine minus sine can take out. But for cosine, you cannot take out. You cannot take out. Okay? Can. Good. Then the minus sign take out already. Sine pi by 3 is sine 60 degrees. Then you will get root 3 over 2. Yeah. Root 3 over 2. With a minus in front. Okay, can. Then you now just multiply the 2 inside. You get 1 minus root 3i. Is this clear?
Yeah.
Oh, finally. Okay, then we are done with the x plus y. We can move on. Find the exact real and imaginary parts of w times z. So over here, what we can do is use the w and the updated version of w and z. Then we can just multiply -1 minus I times 1 minus 3i. Blah, 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 blah. We'll eventually get to -1 minus root 3 plus bracket root 3 minus 1 times I. Do I need to explain this one?
No.
Don't need, huh? Okay, good. Then you get this. So how do you get the real part of WZ? You just look at the left-hand side, the real part without the I. How do you get imaginary part? You just look at the number in front of the I. Why do you want to do that? Because that's what the question asks for. Exact real and exact imaginary. Can understand?
Can.
So far? Okay, good. Then now you want to hence show that sine pi by 12 is this exact value. Very rare question, but possible to come up. So there are a few methods. So method 1. We just review this diagram. What we have found out is WZ is equal to this plus this I. Right?
Yeah.
And we also found out from the previous part that R is 2 root 2 and the theta, the argument is 11 pi over 12. So there are two formats. This is the REI theta format, and that's the x plus yi format. Okay. Then what do? We can just compare the imaginary part. Does it make sense? So root 3 minus 1 times I, and here you got 2 root 2 multiplied by sine 11 pi over 12 times I. So it's sort of like the coefficient, but don't say coefficient, say the imaginary part. Okay. They will be equal, right?
Yeah.
Okay. And somehow, just nice, we got 11 pi over 12. So that means that we can make us, in fact, it's sine 11 pi over 12, which is what the question asked for. The question is asking us to prove that, if I can just bring the question down, I'll paste it over here for reference. The question is asking us to find the value of, prove that the sine pi over 12 is root 3 minus 1 over 2 root 2. So over here, I got sine 11 pi over 12. I'll just make it the subject. I'll divide by 2 root 2. Why do I want to do that? Because 11 pi over 12 is the same as pi over 12 when I take the sine. This is the basic angle, the alpha. 11 pi over 12 is somewhere like here. And the alpha is here. Or the alpha is here, which is just pi by 12. The diagram they draw here. Can you understand this diagram? These two angles?
Yeah, can.
Okay, so that's why sine is equal to sine. You will take a positive value because here is quadrant 2. Oh, remember ASTC.
Yeah, can.
Okay, good. Then that is really just root 3 minus 1 divided by 2 root 2. And then we are done. Shown. That's all. That's all. That's it. Okay, that's method 1. Understand?
Yes.
Okay, next one. Method 2 from the Argand diagram. They just draw Argand diagram. It's basically the same argument. Then they conclude that sine pi by 12 is root 3 minus 1 over 2 root 2. How did they get that? They start off with WZ equals to this guy. So this is a real number. There's a length -1 minus root 3. Okay, maybe I should write this down. -1 minus root 3. And then they have a imaginary part, root 3 minus 1. So that means that this length here is root 3 minus 1. Oh?
Yeah.
Vertical length root 3 minus 1, horizontal length -1 minus root 3. And what about the hypotenuse? You can use Pythagoras theorem, but more simply, it's really just the formula for the modulus of a complex number. Square root a squared plus b squared. That's my a with a negative sign, and that's my b. Okay, square root a squared plus b squared. It's just Pythagoras theorem. Then you get 2 root 2, which is what we found from the previous part.
Yeah.
Is this clear so far? Okay, then
Yeah.
you just draw diagram. Because we know that this is theta is 11 pi over 12, I can draw the 11 pi over 12. And then I do a bit of geometry. I know that pi minus pi by 12, I'll get my pi over 12. Okay? Then from there, you can take sine pi over 12. What is sine pi over 12? So, opposite over hypotenuse. Opposite over hypotenuse. Then root 3 minus 1 over 2 root 2. Can?
Yeah, can.
Opposite hypotenuse, this one just use so. And then we are done. Yay, shown. Exact value.
Mm.
You can verify with a calculator. Root 3 minus 1 divided by 2 root 2. I think, what is it? Root 3 minus 1 divided by 2 root 2. You will get 0.258819045 according to my calculator. Sin pi by 12, you can also calculate it equivalently. Just make sure your calculator is in radian mode. Oh yeah, did you know that you can change the mode in your GC?
Change to what?
Radian mode and degree mode. By
Uh,
default, it should be in radian mode.
No.
It's not very dangerous. Better share this. Okay. Turn on.
Oh, okay. One is in radians.
Yeah, I believe it's mode, right? You have to choose. By default, it's in radian mode. Yeah. Can see or not?
Yeah.
Radian degree. Yeah. So please choose carefully. You don't go and use the wrong mode. Degree mode, then it will be 30, 45, 60 degrees. So like for example, sine of 30, it's in degree mode currently, so it will interpret as and then over here they say degree, right? You see or not?
Yeah.
It's to tell you it's what mode. You will get 1/2 of 0.5. You want the fraction, you press math frac number 1, enter. You get 1/2, convert to fraction. Okay. Can I make sure you're in the correct mode? That's the mode button for mode. And then you change to radian mode, enter. Notice the change from radian, the top corner here, it says radian. By default, it's radians. 28 on, 28 on. Yeah. 28 on is to reset. Okay, can go back to my iPad. Wait. Okay, can back to the screen. This is how you get sin pi by 12. Okay, then wow, it's already 12:30. We still got around until question 25. That's like 10 more questions. It's gonna take quite a while. How should we do it? How should I assign you new homework? Complex numbers.
I don't know anything.
Okay, let me see if there's any specific questions I should go through. All these are prelim questions already, which are like quite difficult. Quite difficult. I also haven't finished marking. So, okay. Can you understand the solution key actually? Well, if I ask you to mark your work on your own, then you can come back and tell me which questions you want me to go through.
Can.
Would that be better? So I don't go through all questions.
Yeah, can.
Can, huh? Yeah,
Yeah.
then you can mark it on your own. Let me know which questions you are really confused by. The next lesson, we will go through those specific questions from this tutorial. I will also assign you additional homework, also another 20 plus questions on complex numbers. You can try that. Then we'll go through it. And I think that will be the last lesson on complex numbers.
Okay.
Okay, I'll move on to a new topic. I think I will go to, do you want statistics or do you want integration?
Integration. I think my pure maths is a bit harder to understand. Now I'm doing like stats on my own for now.
Yeah. Can keep doing it. Keep doing it. Okay. Okay, I think pure maths is the majority of the score for H2 maths. So you should be focusing more on pure maths, okay, to be honest. Okay, I'll go through integration. Can.
Okay.
All right. Then that will be all for today. Later then I will send you the homework. You can go and look through the solution. I'll finish marking up the rest of the 5 questions that I haven't finished marking. And then that will be all for today.
Okay, can.
Okay,
Okay.
Okay, wait, one more thing. Just to recap on some of the important points that we learned today. You don't just always substitute z with x plus iy. Don't just always substitute z with x plus iy. Like for example, from the very first question, you substitute z with x plus iy, you're slowing yourself down already. Sometimes you can just solve for z directly like this. like make Z the subject.
Mm.
For here. Another point to bring up is when you are trying to solve, like when you are trying to do, like for example, this kind of power 2. No, not this question. You said this question. No, when you're trying to do like power 2 or power 3, try to use a GC as much as you can. Or use binomial expansion. Don't do it step by step, very slow. Okay, like for example, this kind, 1 minus 4i bracket square. You missed out a negative sign. This one a bit wasted because you could just directly use a calculator. You see, you can write down whatever working just to satisfy their requirement of not using a GC. But then at the end of the day, just cheat. I'm not saying cheat, but use a calculator and get the correct answer, then copy the calculator. You cannot tell me that you copy wrongly from the calculator. That's unacceptable. You do it manually, then you're just working hard unnecessarily and wasting time, actually. Just use a calculator, get the minus 15, minus 8, write it down, and then you can continue. And that's a second point. So number one is don't always, okay, maybe I should write this down somewhere. Okay, hold on a second. Where should I write this down? Somewhere in your marked worksheet. I'll write it at the beginning. Lesson. This is a lesson of the day. Number one, don't immediately sub z equals to x plus iy. Solve, or rather make z the subject. Easier. Number two is use GC. Trust the GC. Copy directly from GC. Copy the answer from GC. Okay, the other point I want to bring up that's related to it is when you're, for example, solving like minus 1 plus 3i power 3 ... Use, if you really need to use manual, if you really need to expand it manually, please use the binomial expansion formula. It's faster. There's only 6 terms. Oh, wait, 4 plus 1. 5. I am not, brain is not working. 3 plus 1 is 4. Yep. There's only 4 terms. Easier. Or you reduce careless mistake. Reduce careless mistakes. Okay. Yeah. Don't manually expand. Don't do it like -1 plus 3i times -1 plus 3i. You get whatever answer. And then you take whatever answer, you multiply it by -1 plus 3i again. Not recommended. Very, very slow. Okay. Can use calculator, use calculator. Okay, that's number 2. Number 3, use part 1, solve part 2. You need to know how to be able to use the part 1. Like for example, in this square root question, you need to understand that what they are hinting at you, express this in the form of a plus bi, is that there's a 15 plus 8i, there's a minus 15 minus 8i, they are related. They are related. And then you need to realize that what this question actually is telling you is the square root of 15 plus 8i is 1 minus 4i, plus minus. Or in other words, you can, or maybe you can rephrase it such that the square, you avoid plus minus square root, you just rewrite it as something square, which is what they did here. They rewrite it as 4 plus I square, then you can substitute in. As in, you can not substitute in, you can just take the square root on both sides. Sorry. Okay, use the part 1's answer basically. Okay. Yeah. Any other points to take note? Yes, one more major point is the 1 over a plus bi. It is not the same as splitting up as separate fractions. I think you did that. Yeah, no, this is totally wrong. Wrong. Okay, you cannot split up like this. What happens when you see a fraction and you see a complex number at the bottom?
Must realize the denominator. So I times the conjugate.
Yes, correct. Top and bottom. So that's our next lesson. Number 4. Oh, no space already. Let me just get rid of the question. Number 4, you need to, when you see this, realize denominator. Okay, multiply top and bottom by the conjugate. Okay, then number 5. Let's see. What's another major mistake you made? If I can recall. Use binomial coefficient. Okay. This one. You never make full use of the REI theta. You just jump straight to z equal x plus iy. I think that's related to point number 1. This is one alternate strategy. You can solve and make z the subject. An alternate strategy would be to replace z with the REI theta format. Okay. Then regarding REI theta, for the extreme cases, what's the extreme case? Like for example, z equals to 6. You can actually straight away rewrite it as 6ei pi. How's the angle? You can tell straight away. Oh, sorry, this should be 0. Sorry, this is 0. Maybe if I just change the number to make it different from the tutorial question. This is 0. If this is 7, then the degree is 0 and the length is 7. Or the other extreme case is what? -6, right? So we get 6ei pi. Because here's -6, the length is 6, and the degree is theta is pi. Make sure you get that extreme cases. And also one more, z equals to, let's say, like -2i. What's the length? 2. What's the degree? What's the angle?
90 degrees. Pi over 2.
No, clockwise or anti-clockwise? Clockwise, right?
So it's negative pi over 2.
Negative pi over 2, exactly. So not just 90 degrees, it's pi over 2. Not just positive, it's negative because of the direction. Okay? Yeah. Okay, extreme cases. This one, no calculation required. No calculation required. No calculation. Draw a picture. Okay, just draw Argand diagram. And you will see it immediately. Don't need any working. What's another mistake you made? Let me just see. If I can recall. Okay, yeah, just make use of part 1. You didn't do that. W cube use binomial coefficient. I already mentioned that. Here, yes. This one maybe it's my fault for not mentioning. Sometimes when you want to solve for the unknown a and b, unknown coefficients, you don't straight away use conjugate root theorem. You can sub in directly with the roots. Then you'll get an expression in terms of a and b. Okay, this one I didn't go through. But in detail. But I leave that to you. Here you use a calculator. Maybe I should mention. Use GC. Make full use of your $200 GC. Here is a bunch of numbers you can key into the calculator. They will calculate for you 2 plus 54i. Yeah, and then you just rearrange it so that you get the real part on the left and the imaginary part on the right. Okay, I'll label this as real. This is imaginary. Then you can equate the coefficients. Because 0 is really just 0 plus 0i. You leave the right-hand side alone. The 0, 0 plus 0i. And then you write real and imaginary. Then now you can get 2 equations in 2 unknowns. Then you can solve. No need to use conjugate root theorem. Okay, let me write that down for you. So number 6 is don't jump straight into conjugate root theorem. Oh, by the way, what's the condition? What's a key condition you need to use conjugate root theorem? The coefficients must
be real.
So if you have complex coefficient, then how?
If like it's a root that I can sub in, then it's equal to 0.
Yes, correct. Good. If given root, now that still applies even when you have what do you call it? Complex coefficient polynomial. If given a root, example z equals 1 plus I, can sub into z. z in f of z. So by factor theorem, okay, I'm not gonna write factor theorem. Just need to know the rule. F of 1 plus I equal to 0. Oh, everywhere you see a z, you replace with a 1 plus I, and it's equal to 0. Then you can compare. CF means compare. CF is Latin for confer. Confer means compare. Compare RE and IM, real and imaginary parts. Solve for A, B. Oh, right. Another important point. When you're using factor theorem, do not recycle the letter. Do not recycle A and B. Use PQ plus Z or something like that. Oh, don't recycle. Make sure. Oh, sorry. PZ plus Q. My apologies. PZ plus Q. PQ brand new. Oh, make sure PQ is brand new. Make sure you get a brand new letter. That was factor theorem. That was another serious mistake you made. What else? Let me see your working. What other mistakes you made? Fine. Oh, here. Make use of a different letter P plus IQ. Then you won't make this kind of mistake. Okay. Right? You understand this one?
Yeah.
Don't write -5 plus 5. Other things. Minus sign. This one is just very blur. You can use GC and you won't make this kind of mistake. Just copy. You cannot. I doubt that you will copy wrongly from the calculator. Oh, okay. Can. All right. Then other mistakes. Oh, it's a mosquito. Oh my goodness. Okay, never mind. Later. So okay, then here your substitution is wrong. You did a 1 over 1 over, which is wrong. You did a double 1 over. That's not correct. So it's algebra mistakes. Algebra, I'll leave that to you already. This one. I won't talk more about it. Okay, another algebra mistake over here should be 1 over 2y. Not y over 2. Okay. Presentation error. Okay, also minor. If you can get the correct answer, then nobody will fault you. The presentation is just secondary later on. Here use a PQ plus Z. PZ plus Q, sorry. Don't use AZ plus B because A and B have been used already. Here you use long division. To be honest, I do not recommend long division. Very long-winded. Very long-winded. Usually the question, if you see that it's starting to get a lot of fractions already, you're probably on the wrong track.
Oh.
Yeah. Okay, maybe I should mention that. Long division. Then long division is a last resort. It's a last resort.
For complex numbers?
Yeah. Usually we factor theorem first. Factor theorem better than long division. Okay? And sub z equals to 1 plus I, so that into this one. So that you get f of 1 plus I equals to 0. I think that's actually that's a faster way to solve questions. Right? Substitute is better than factor theorem, is better than long division. Okay? Yeah. Other mistakes. Let's just continue looking at all your mistakes. Let's see. If I can remember them. What else? Convert to exponential form. Talked about it already. Forget a c square. Okay, this one no choice because there's a c. You have to manually expand. So I strongly recommend using binomial coefficient or binomial expansion. Sorry. Yeah. Okay. Question 12. This one is the manual way. Right, and also you should use the exponential form. I think I mentioned that. Make sure you make use of the REI theta. Or you have 3 tools. Either x plus iy, cosine theta plus I sine theta with a r in front, or the REI theta. These 3. Make sure you use all 3. Okay, not use all 3. I mean, sometimes you need to use all 3. Context dependent. Depends on context. Here the angle, make sure it must be within the principal argument. Stay within the principal argument. Then you can get the correct answer. Let me just write that down. Under RE I theta, maybe point number 9. Okay. RE I theta. Or rather, more generally, the argument of Z. Make sure it stays within negative pi to pi, inclusive of pi. You need to add multiples of 2 pi k to bring it back. Okay. Anything else? Let me see. Okay, that's all we went through so far. Okay, I haven't talked about 15. Oh no, progress a bit slow. Yes, so some more mistakes some more queries that I have is how did you know about this one? How did you know about, okay, I'll talk about this another time, but how did you know about this one? When you raise to the power of n, you multiply the angle by n.
I think I searched online.
Don't search online. This is actually removed from your syllabus. You are not allowed to know this technically, or not allowed to use this. You need to, if you want to use it, you have to prove it first. It's called De Moivre's theorem. Okay, the proof is very simple. Let me show you. I'll just show you now. If you got Z equals to R1 EI theta 1, you got then you raise it to the power of n. What does this is really just R1 times, actually I don't need the 1. This is really just R times cosine theta plus I sine theta, correct? Okay, good. Then that's not enough because we are now going to figure out what's Z to the power of n. Let's see which is easier to raise to the power of n. This guy or that guy? The first or second?
The first one.
The first one is easier because it's already exponents. Then you raise to the power of exponent, of course it's easier. Speaking the same language. So you get R power n times e to the power of I n theta, correct or not?
Yeah.
Okay, then that means that you have R power n on the outside multiplied by e power I n theta. The angle now is what? Is it just theta or is it n times theta?
It's n theta.
So that means that you can replace with cosine of n theta plus I sine of n theta. Okay, but wait, what is that? What do we do here? We raise z power n, but we know z is r cos theta plus I sine theta. So doesn't that mean that this would be the same as raising this whole thing to the power of n?
Yes.
Which is really just the same as r power n times cosine theta plus I sine theta, then the power n is outside. Then we have proven something very magical. Whenever you got cosine theta plus I sine theta, bracket raise power n, you just need to bring the n inside. Bring the n inside. Oh, so the conclusion is cosine theta plus I sine theta whole thing raised power n is just cosine of n theta plus I sine n theta. This is in further max. You are not supposed to know this. If you want to use it, you need to prove it. I don't recommend proving it. What you do know how to do is to raise exponential to the power of n. So over here, you're supposed to use exponential, ei theta, and then you raise power n. Where the theta in this case, I think it's pi by 6. Pi over 6. I say pi by 6 means pi over 6. Pi divided by 6. Okay, so I'll go through this later. Next week. And then I'll give you some I'll give you some extra homework. Oh yeah, and trigo equation, just take note of that. I'll send you the file later. You can go and look again.
Okay.
Okay, yeah, then that's all. I think so. Yeah. Oh, one more point about here. Question 19. The negative one should be a negative 100. I don't know what went wrong. Square root of negative 100 suddenly becomes square root of negative 1. I don't know what's going on.
Oh no.
Yeah, you try and figure out what went wrong.
I think I just pressed the calculator only.
Yeah, because you cannot afford to make this kind of mistake. It's only part one.
Yeah.
It's only part one. Later on, part two, we need to use part one. So if you make a mistake in part one, well, you know what happens. Okay, Ken. Also more careless mistakes. You missed out some coefficients. I haven't had time to talk about it. I'll talk about it later. I mean next week. So let's just draw a line at question 15 to remind myself. Yeah. Sorry. Okay. This is what's the date today? Is 1st July. 220701. Okay, Ken. Then we'll continue next week. That's all.
Okay, can.
Okay, I'll give you more practice questions.
Okay.
Okay, Ken. Thank you.
Okay,
Bye-bye.
thank you. Bye-bye.
Bye-bye. Okay, stop.